Um, Recording on progress. So thank you everybody for being here. Your exam is upcoming, and I want to let you know that tonight we're going to be able to go through all the material you're going to need to succeed on your exam, as well as showing you all the different tools that you would really need to make sure that you have everything on your side to be able to do all right on the final. So what we're going to be going through tonight is a mock exam, and through that mock exam, I'm going to explain different topics that are really, really crucial to your success, as well as really giving you the know-how and the approach needed to succeed. Also, I like to make these sessions kind of interactive and fun. So you don't have to put in your camera or whatever, but I will be going through the questions together with y'all, and I expect, for you to say true or false, or to try to answer the question as much as you can, because that's really how you're going to get the most bang for your buck. And yeah, so before we get started, let me just show you different tools that you have to your disposal that we could maybe check out together prior to starting today's session. So if you could see right here, what I want to show y'all is first and foremost, if you go on the website ISMA Helps and you select Comp 308, you're going to see, I'm sure you already know all of this, I'm just going to do a quick spiel. You're going to see the exam notes, and the exam notes cover every single chapter that is in the exam. And what I think is really, really interesting is more so the latter chapters, which discuss the different formulas you'll need for capital budgeting, as well as the different perspectives I would typically apply when doing these sorts of questions. So maybe something to check out. And it's one additional tool that you could have to succeed. And then the free practice problems. Listen, there's literally 72 pages, maybe more than 100 questions available here. And this is really what I would recommend going through if you have the time and if you really want to test yourself to the best of your capabilities. It's really all the questions possible that you could have on the exam, and the answer is also provided. And then finally, another tool that I believe is really important, for example, it's if you go on welcome to my YouTube channel. On the YouTube here, you see that I have a bunch of different videos that cover topics that you may need on your exam. Okay, for example, there's this video on how to master beta. It's something that's an easy question that you could go through, and this is a step-by-step. There's a reason why they're long. It really brings you through all the different topics that you would need to master. And then finally, I know I'm going on and on and on, but I just want to make sure that you know all the different tools that you have access to. So on your member page, if you book the session, you have access to the studying material. And the studying material is, once again, all the different things that you would need to succeed. But then you also have access to this recordings section, okay? You could have access to the recording section right here. And this is where we're going to put the solutions to tonight's mock exam, as well as the recording for tonight's mock exam. But because I really want to help y'all out, I'm also going to include the recordings from the first exam and the second exam, such that you have all the tools available to you to master the different chapters that you feel you need the most help with. It's something that I believe you maybe should use. It's completely free. It's available to you. If you have questions about the member area and you're not too sure how to navigate it, just send me a text after tonight's session. This is just another tool that you could use to, once again, master the different questions that you may need, right? And I didn't say this in a group chat, but the questions that are on, the crash course are questions that are from past exams, past tutorials, questions that I've looked over with teachers at Concordia, made a few friends there, and these are relevant questions. So understanding the step-by-step will allow you to have the reference points that you would need to answer those curveball questions that they may send to you on the exam. All right, so that's pretty much my spiel on the different tools that you have accessible, that you have access to really master your exam. It's something that I just think is a no-brainer. So before we begin, I didn't introduce myself. Obviously, Ismail Francion, ISMA Helps. I'm the guy that spams, Casa James B all the time. But what I want to tell you a lot is that Comp 308 for some is actually going really well, but for others, the average is still trending towards 50%. And what I want to tell you is that me, when I took the course, I really had an upwards trend from the first exam to the final. And my idea here is that if you just did a little bit better on exam 2 than on exam 1, you're on the right track. And if you're here, you're on the right track. And when I took this course a long time ago, low-key, when I took the course, I didn't do so well on exam 1, but I just kept on working and kind of just refining my reference points, such that on the final, I was able to do extremely well. So trust me that there's no surprises coming to you as of now. And on the final, I think you're going to have 30 or 32 questions, I believe. And from those questions, you're going to be able to do much, much, much better than you think so. Listen, I had like not the best grade on exam 1, and on the final, I believe I had like a 94 or 97. It was just because you keep on working hard. And all the questions that I went through to get to that grade is the questions that you have access to as of tonight. So with that said, that's my spiel. Let's get started. Yeah. So before we begin, everybody, do you have access to the tools to the mock exams? Just say yes really quickly, because we're going to be going through it together. Yeah, cool. Amazing. Good. Okay. So with that said, question 1, how we're going to go about it is a set of true or false, a bunch of different statements. And these are statements that were on previous exams or on tutorial questions. I want you to say true or false. And from there, we're going to kind of debate and have a talk, like a conversation on each. So match the following statements to true or false. The discounted payback period is longer than the simple payback period because the future cash flows are worth less. So the discounted payback period, all right, versus the simple payback period because the future cash flows are worth less. Now, what do you all think? Is it true or false? Alexander said true in a direct message to me, so maybe put it to everyone low key. So I need y'all to answer true or false. I need at least 3 people to answer, and then from there, we'll break it down. So we got 1 true. What do y'all think? Is it true or is it false? I don't know. Amazing. Good stuff. Okay. Yes, the answer is definitely true. Amazing. I'm really happy that we all got it. So yeah, the answer is true. I'm just going to zoom in a little bit to make this easier for us. By the way, quick question. If I put the camera here, do you guys still see me really quickly on the chat? Yeah. Okay, cool. Amazing. So, yeah, the answer here is definitely true. This idea here is that the discounted payback period is longer than the simple payback period. And the reason why is because literally, as the question states, we're discounting our cash flows, right? So if we're discounting our cash flows, obviously our cash flows are going to be worth less, and it's going to take much more time for us to recapture our initial investment. Okay, let me say this one more time. I believe everybody understood. But because we're discounting our cash flows, they're worth less. And because they're worth less, it'll take us much more time to recapture our initial investment. Okay, I believe we're all good with this. And if you have a question, do not hesitate to stop me, to raise your hand or whatever, or just speak out. We'll go through it together. Okay, so with that said, still on the discounted payback and all that good stuff. The discounted payback period is longer than the simple payback period because of the PV of the cash inflows are worth more. Now, is this true? Do we even need to debate on this? Is this true or false? What do y'all think? Alexander says false. Is this true or false? We're saying that the discounted payback period is longer than the simple payback period. Okay, we got 3 false. Amazing. Good stuff. Good stuff. So yeah, the answer is definitely not good. It is false. And the idea here is that we already know that the discounted payback period on average will be much longer than the simple payback period. So already there, okay, already at the very beginning of this question, you have a clear indicator that this is probably a false statement, okay? And we also know that the present value of cash flows are definitely not worth more because we are discounting them, okay? Impossible due to discounting. Okay, this is just does not make sense. And for that reason, this is false, all right? Now, this is the fun stuff. I know y'all love IRR and NPV. So let's look at this. Let's look at this together. Oops, there you go. IRR decisions can be reliably used to choose between mutually exclusive projects. IRR could be reliably used to choose between mutually exclusive projects. We have two concepts here. So I have one false by Alexander. What do y'all think? Is it true or false? I have one false from our boy Alexander. What do y'all think? I need two more answers. We got another false by Yasmin. She could be right. I don't know. We need one more answer. One more answer. Maybe y'all are right. Okay, perfect. Yeah, the answer here is false. The answer here is most definitely false. Now, what I want y'all to think really quickly about is that, sure, IRR is definitely something that we could look into when discussing investment decisions. It's a really good indicator. It tells us what is the rate of, like, what is the interest rate or discount rate we could imply to have an NPV equal to 0. However, when we're looking into mutually exclusive projects, can somebody tell me in the chat what we need to use when we're looking at mutually exclusive projects? What metric do we use for that? Okay, so Kjell says NPV, Elisa says NPV, Yasmin says NPV. Okay, Alexander says K in crossover rate. And that's why I want to spend a little bit of time on this. And by the way, these are in my notes. Okay, so please take a look at the ending of my notes. But when we look at mutually exclusive projects, yes, we're looking at some sort of NPV, but what we're really looking at is what we call, okay, we look at what we call the EANPV. All right. And the EANPV is like the NPV, but it's standardized because we may look at different mutually exclusive projects with different timelines. Okay. So this is a sort of NPV that is standardized. And don't you worry, we're going to look at a concrete example for EANPV. But I just want to make it clear to y'all that when we're looking at projects that are mutually exclusive, who may have different timelines, we use what we call the EANPV. A slight distinction, okay? NPV and EANPV aren't necessarily the same thing. But all in all, for C, y'all did the right thing. The answer is false, okay? So now let us look at D. Are we all okay with this, by the way, really quickly? C, are we all cool with this? Quick Y or yes in the chat, you know? Okay, amazing, cool. Beautiful. Okay, so if a project has a discounted payback period with the acceptable time, and it has conventional cash flows, it cannot have a negative IRR. If a project has a discounted payback period within the acceptable time, exactly, Yasmin, you're totally true. You're totally correct. That is for EANPV, yes, 100%. And for D, what are we saying here? So if a project has a discounted payback period within the acceptable time, it has conventional cash flows, it cannot have a negative IRR. Is this true or false? So we got two trues in the chat, I believe. Okay, we got two trues in the chat. I need one more answer. True or false? Y'all could be right. Y'all could be wrong. I don't know. Who knows? We don't know yet. I need one more answer. True or false? Une autre réponse. True or false? One more. Okay, so we got three trues. Oh, we got Yasmin with false. Okay, all right. So the answer here is actually false. All right, the answer here is actually false. Now, let me tell you why. And this is something really interesting to understand, all right? And this will apply to both payback periods, okay? So look at this idea. So we have our normal payback period. And we have our discounted payback period. What's interesting with these two metrics is that the time we consider is set arbitrarily. It's not set in an objective way. It's really subjective, okay? The time period that we look at within a payback period and a discounted payback period is ultimately set by the investor. So for somebody, it could be 25 years. For another person, it could be 3 years. Their payback period that they deem acceptable could fluctuate from person to person, company to company, okay? So for example, this is Jake. Jake's payback period for him, which he deems acceptable, is 4 years. But then we have Lucy. Lucy believes that 40 years is an acceptable payback period, okay? So it's completely subjective, and that does not deem that a project will have a positive or negative IRR, because a negative or positive IRR is directly related to the cash flows, okay? So for that reason, it's not 100% correlated that if a project has a discounted payback period within the acceptable time, that this IRR is positive, that this IRR is interesting for us, okay? It could have a negative IRR, all right? So for that reason, this answer is false. What I'm really trying to say here, just to make it super clear, is that a discounted payback period could be fulfilled, but it may not have a positive IRR, okay? Just to be completely clear here. Does that make sense to everybody? Do we understand that the IRR is a little bit more objective, but the payback periods are a little bit more subjective, and for that reason, they're not 100% correlated? Are we all okay with that? And for that reason, this is false. Yeah? Okay. If you have any questions, now's the time, all right? Because I could clear it up. But if you hold your peace, you hold your peace. Okay, cool. So let's look at E. E is also pretty interesting. Assuming a cash outflow in year 0, okay, followed by cash inflows in all following years. Can somebody tell me what this means? Assuming a cash outflow in year 0, followed by cash inflows in all following years. What this means for you, essentially, it means that we're looking at conventional cash flows, okay? So when you see this in your exam, if they say something like that, don't get confused. This just means conventional cash flows, all right? Sometimes on exams, they like to say things with different sentences, different wording. Okay, so if the NPV of project is 0, then the IRR of the project will be equal to the discount rate for the project. This is really interesting. So if the NPV of a project is 0, then the IRR of that project will be equal to the discount rate for that project. Is this true or false? Okay, amazing. Wow, you guys all are pros. Yes, the answer here is true. Nice. I'm proud. The answer here is 100% true. If your NPV is equal to 0, that means that your cash flow over 1 plus K, right? And gave you 0. And we know that IRR will be the discount rate that gives you, that yields NPV equals 0. For that reason, this is true. That's amazing. This is like a question that you typically see on an exam. And if you're able to get this like that, you're a pro. All right, nice. So let's look at F. Let's look at F. The NPV and IRR methods will always result in the same accept and reject decisions when the cost of capital is less than IRR for 2 independent projects, okay? So the NPV and IRR method will always result in the same accept decision or reject decision if the cost of capital is less than IRR for 2 independent projects. So this is interesting. Now, is the answer here true or false? What are we looking at? Is the answer here true or false? We got Alexander, I believe, with false. I need 2 more answers. We got 3 false. Okay, amazing. Yeah, 100%, 100%. And really quickly, Yasmin, in this case, when we're looking at independent projects, essentially it means that they're not mutually exclusive, okay? So That's one way to look at it. Don't get too like caught up on the independent project part. Right now, what we're really going to look at is the relationship of NPV to IRR. Okay, we're going to try to break that down, and it's going to give you an understanding to why, if the cost of capital, if it happens to be less than IRR, that it may result to the same decision or not. Okay, so for this question, the answer is true. All right, the NPV and IRR methods will always result in the same accept and reject decision when the cost of capital is less than IRR. Okay, this part right here, I'm going to say it right here, and you can write it in your notes as well. By the way, the answer here is true. Don't mistake this for mutually exclusive. Okay, don't mistake that for but for this, like what I meant by don't mistake this for a mutually exclusive or EANPV consideration is that I mean that in this question, we really want to get a better understanding of the relationship of the NPV to IRR. All right. And this is a really good opportunity for us to try to get a better sense of what it means to have a cost of capital that is less than IRR. Okay. So let's say that our cost of capital, okay, let's say that IRR, and I'm going to give you all a practical example to make this much more obvious to us, and then we could apply it through a timeline. You'll see what I mean. Okay. So let's say that IRR is equal to 10%. Okay. And we know that our cost of capital is less than IRR. Okay. So we could say, for example, that our cost of capital is equal to 1%. Okay. So we know that our cost of capital is less than IRR, and for that reason, it's less than IRR, it's 1%, okay? So can somebody in the chat tell me what happens if our IRR is equal to zero, if our NPV is equal to zero, right? What happens when our NPV is equal to zero? Does that mean that IRR is essentially equal to the cost of capital? If our NPV is equal to zero, does that mean that the cost of capital is equal to IRR? Ashil in the chat says exactly, IRR equals K. So if our NPV is equal to zero, that means that our K is equal to IRR, all right? But what happens if we have, for example, a cost of capital of 4%, okay? What happens if our cost of capital is 4%? Does that mean that we are looking at a good project? Does that mean, okay, no, even better. What happens if our K, okay, is 4%, but we know our IRR is 10%? Will our NPV be bigger or smaller than zero? This is a curveball. I'm going to try to have a little discussion with y'all. So if our K is 1%, will our NPV be bigger or equal or smaller than zero? And we know our IRR is 10, okay? If K is equal to 1%, will our NPV be bigger, smaller, or equal to zero? Can somebody tell me that in the chat? You don't even need to do any math. You just have to like really try to understand. I need at least 4 people to answer, all right? So at K equals 1%, NPV is then 0. So if K is equal 1% and we know IRR is 10%, NPV is what? Then 0. Is it smaller, equal, bigger? Okay, so Alexander says greater. Amazing. I need 2 more people to answer. What happens? Elisa says bigger. Monica says bigger. God bless you. Amazing. Yes. Okay. Exactly. So what I tried to say here in a really like stupid and funny way was that IRR is the point at which our NPV is equal to 0. And what this means for us is that any discount rate below the IRR will result in an accept decision, okay? What this means, once again, our IRR is the point of break even. It's the point at which we get to 0, such that any point before our IRR will mean that our NPV will be bigger than 0, and it will also mean that we must accept the project, okay? And for that reason, if our cost of capital is less than IRR, we will always have the same accept and reject decision. Reject, in this case, you won't, but you will have the same decision no matter what, okay? And that's the way the teachers really wanted you to look at it, all right? So if you want a visual representation of this, and this is something I typically use, this is our IRR at 10%. Yeah, just give me a second. And we could say that we have a point here at 0%, and we could have a point here at like 15%, okay? Such that, this, any point below our IRR means accept for our K. However, any point above our IRR would mean reject. So our IRR really is like the breaking point. Is at that point that we never, ever really, like after IRR, it means reject 100% if our K is bigger. But before our IRR, if our K is smaller, that means accept, okay? So in this case, if our cost of capital is less than IRR, then 100% we're gonna have to accept, okay? And for that reason, it will always yield the same result. Now, this was just me trying to really give you the best sense of what this IRR thing really means and what's this relation to NPV. But I know I spoke a lot. So really quickly, does anybody have questions or rebuttals or ideas about this topic? Or was this clear? Did this make sense for everybody? That's my biggest question, I guess. I guess quick yes or no in the chat. Makes sense. Okay, perfect. Cool, amazing. So that's what it really means here. So little summary. If K is smaller than IRR, it's an accept. If it's bigger, it's a reject. Okay, you can write that into your cheat sheet. It's literally the golden rule, assuming conventional cash flows, of course. So assuming a cash outflow in year 0 followed by cash inflows in all following years. So this just means assuming conventional cash flows. As the discount rate is increased, the IRR decreases when the NPV decreases. This is a funny one. It's pretty interesting when you try to break it down, but I want to know what y'all think. So as the discount rate is increased, the IRR decreases and the NPV decreases. All right, what do y'all think? Is the answer here true or false? We have one true in the chat. We have one true in the chat. Is the answer here true or false? Maybe Alexander is right. Who knows? I don't know. We got 2 trues and we got 1 false. I need a tiebreaker maybe just for fun. It's not really a tiebreaker, but I just want to see somebody else. True or false? What do y'all think? One more person. True. Okay, so we have 3 trues and we have 1 false. The answer here is actually false. And I'm sure you've seen some booklets that may say true, or that, you know, a friend said true, or whatever the case may be. But what I want y'all to understand here, and I kind of spent a lot of time going over this one just to really make sure that it's clear. But our IRR, assuming all else constant, does not change. Our IRR for a set of cash flows will always remain the same. Okay, our IRR, as you can see, is the breaking point. There's only one point, assuming like normal cash flows, at which our NPV is equal to 0. Okay, so an IRR could not increase or decrease based on any other factors than cash flows. So already there, we know that this is completely false. The discount rate will not impact our IRR. Okay, for that reason, this is false already from the very beginning. Okay, so if our discount rate increases, the IRR will not decrease. The IRR will remain the same. If the discount rate decreases, the IRR does not change. All right. However, the bigger our discount rate, I like that question, Alexander. It's an amazing question. So, and I'll kind of like do a parabola, or like I'll go on a tangent here. So the relationship, okay, the relationship between K and NPV is as follows. So if our discount rate, okay, increases, this means that NPV will decrease, okay? If our discount rate decreases, this means that NPV will increase, okay? So that portion, this portion right here is true for sure, 100%. If the discount rate is increased, 100% the NPV will decrease. But saying that the IRR fluctuates is not true. It's not how it happens within conventional cash flows. But since we're here, I would like to kind of expand on this topic, which I'm sure all of you are pros, but it's still really interesting to consider, is that the reason why we say that as K increases or NPV decreases is because the following. K is equal to like one's rate of return, okay? I'm sure you've heard this as well as you studied for the later chapters. K is also what we call the cost of capital, okay? And you could really think of K as being your opportunity cost. So I'm throwing a lot of words at you because I'm sure you've seen these around throughout your time at JMSB or throughout your time taking Comp 308. So let me just say this one more time. K could be considered as one's rate of return, its cost of capital, or its opportunity cost. What this means is that for K to look at an investment or K to look at a project, or I mean, for a person to look at an investment or a project, they would have a cost of doing so, okay? And that's why we essentially try to see if an IRR is bigger than our cost of capital, because that's what's really interesting for us. That's where we make our gain, but I'll digress. So the idea here is that as our K gets bigger, okay? And let's say our cash flows is equal to 1,000. So let's say we have 1,000 and our K, we set it at, for example, call it 1%, all right? Can somebody do this for me? If our K is equal to 1% and we discount $1,000, what would be our answer? So 1,000 divided by 0.01. That's our K. Our K is 1%. What would be our present value? Amazing. So we have 100 grand. What happens if our K is equal to 10%? What will be our present value? It's pretty straightforward, but exactly 10K. So already there, we understand that the higher our K gets, the lower the present value of anything we look at, of any monies we look at, okay? So for that reason, that's 100% true, and that's a visual way to understand what we're talking about here. But I would like to go one step further for y'all, and don't feel too worried about it, but essentially what's really interesting with our IRR and in relation to K and our NPV is our IRR is telling us that that's the point at which you would want to look compared to any other investments. So let's say your IRR for a real estate investment is equal to 20%. What this means for you is that any other project that gives you less than 20% is not worth it for you, okay? So this is the idea, and that's why our NPV is higher if our cost of capital is lower. Because let's say for yourself, let's say your parents, they would invest in bonds or something of that sort, or something not really risky at 2%. They would get a very high NPV if their cost of capital is only equal to 2%, right? They would be closer to 100 grand than into 10K. Does that make sense to everybody? The smaller one's essentially cost of capital, the higher present value of their investment. So that's something that you may want to try to understand, and it's going to make much more sense if you're in finance and you want to go into different courses like FINA 395 or FINA 412 or FINA 411. These are things that understanding now kind of gives you a better grasp. Okay. So anyways, that's the last of my spiel. So is everybody okay with the true or false questions that we did? And we're ready to move on to our computer crossover. Yeah, cool. Amazing. Once again, if you have any questions, don't hesitate to ask. So this is really fun. what we're going to do essentially is we're going to try to get a better sense of what happens with these crossover rate questions. And there's two ways to go about it. Okay, cool. Really good question, Mohammed. So IRR will only fluctuate based on the cash flows. Okay, essentially IRR will only fluctuate based on essentially our initial investment and the continuing cash inflows from there, or cash outflows. Okay, so only cash inflows and time could really cause a change to IRR. So that's what you would want to look at, the cash flows essentially. Right, so this right here, cash inflows and so forth. No problem. Okay, so these questions are really, really fun because you could try to get a sense of essentially what we're looking at when we're looking at incremental cash flows, when we're looking at two mutually exclusive projects with questions like these. And I could promise you, you're going to see a question like this on the exam. And what I'm going to do now is essentially show you the quick and easy method to go about it. All right, the quick and easy method. All right, so let's go about it together. So Nike is considering two mutually exclusive projects. That's really cool, amazing, good stuff. And the projects are A and B. The projects have the following cash flows in millions of dollars. The crossover rate of the projects is 9%. And now we're asking you, what is the cash flow for project B at time 3? Okay. So this question is a little bit different than the classical classical incremental cash flow question, because we're already giving you your crossover rate. Now we want to seek a specific cash flow. We want to seek a specific point, which is right here. Okay. So before we begin, I kind of just want to expand on the crossover point just a little bit. Okay. And the crossover point's really, really interesting, and it's actually pretty logical. So we're going to go step by step with this, and please do not hesitate to ask me a question. And I know I talk a lot, but just please don't hesitate to stop me or say, Ismail, go on. Okay. So when we look at two different projects and we're considering their NPV, we could actually plot a graph to get a better sense of this. And this is going to help visual learners a lot. So let us do that right now. And by the way, this is something I definitely recommend putting on your cheat sheet if you are struggling with these types of questions. Now, this is a terrible looking graph, but who cares? So we're going to put on our horizontal axis our K, or our interest rate, or our discount rate, whatever. And we're going to put on our vertical axis our NPV. All right. So essentially what we say here, when we're looking at the crossover rate, we're trying to see, essentially, in a very logical fashion, for example, we're trying to see, let's do this. Let's look at these two lines together. Okay. So as you can see right here, I'm gonna ask you a really stupid question. What is that point that I just drew? That I've drawn on the thing. What is this point called? What is this right here? Perfect. Exactly. We're all on the same page. This is what we call our crossover rate. All right. This is what we call our crossover rate. And now let me ask you another question. All right. At our crossover rate, can we agree that, I can even draw it out small, put it like this. Can we all agree that K prime, NPV prime, can we all agree that their NPV and their K will be equal to the same thing? Say yes in the chat, please, or no. Can we all agree that at the crossover rate, project A and project B will have the same NPV and the same K? Yeah, 100%. You get, all of you are pros. I love it. So yeah, that's exactly why this is really interesting. And we know that at the crossover rate, A and B will have the same K and NPV. So what does this mean for us? Essentially, this means that if we know that their NPV will be the same, and we know that their K will be the same, essentially, we can make the argument that the present value of their cash flows together will be equal. Okay, so if we know that their NPV and Ks is the same at the crossover rate, all right, that essentially means that their cash flows, when discounted, all right, will be equal to 0. So that's why when we do the following steps, it makes sense to look at our incremental cash flows and discount them by the crossover rate to find any missing cash flows or to work in a different fashion. So this will make more sense in 2 seconds. Now, enough with the spiel. When you see a question like this, the first step to do, and we can do it together, is that you want to look at the difference between A and B, or you want to do B minus A, for example. So what we're going to do is for every single year, we're going to find the incremental cash flow, and we're going to discount it by the crossover rate. So can somebody tell me what's B minus A for time 0, time 2, and time 3? So what is B minus A at time 0? So what is this minus this? Nice, perfect. And then what is 1.7 minus 2? B minus A. I think there's a little typo in the thing. What is B minus A for project B at time 1? Right here. Nice. Then 3.2 minus 3. I can do the math, but it's more fun if we do it together. There you go. And then finally, for year 3, we're dealing with an unknown. And if you, all of you remember back in high school, when we had an unknown, we like to call it X, okay? So for the matter of this question, because we're solving for this unknown, we're gonna call this X, all right? So in this case, it will be equal to what? What will be our cash flow, our incremental cash flow for year 3? B minus A. What would it be if we know it's unknown minus 5? So we just type it in the chat just to make sure that, you know, perfect. Thank you, Tierno. X minus 5. Perfect. So now we have all of our incremental cash flows. Yeah, nice, Jack. Amazing. So now we have our incremental cash flows from year 0 all the way to year 3. And we already know our crossover rate, okay? So all that is left to do is to essentially discount those cash flows at our crossover rate to find our X, okay? So let's do that right now all together. Now we know, by the way, when our NPV, okay, when we have an NPV and an IRR, essentially, we know that at our IRR, at our crossover rate, our NPV is equal to what? Is it equal to 0, 1 million, 10, 5? What is it? At our crossover rate, our NPV is equal to what? 0. Yeah. And the idea here is that because it's our crossover rate, their NPVs should be the same, right? And because they're the same, B minus A's NPV should be equal to 0. So let's do the following. You can say 0 is equal to incremental cash flows. Discount rate. All right, so for that, we're going to just do the following. So we're going to do 0. I'm going to zoom in a little bit just so I can write a little bit nicer. All right, so we're going to do 0. Plus 0.09. And what will be my exponent here? Will it be 1, 2, 3, 4? This is for year 0, by the way. What will be my exponent? Do I put 5? Do I put 6? Do I put 3? Thank you, Alexander. Amazing. Whoops. So yeah, our exponent here would be equal to 0. And then we're going to do this for the next year. So we're going to have minus 0.3. Then 0.2. And then finally, I always do this at the bottom for whatever reason. Yeah, KAPM, what's up?
Yeah, just wanted to make sure. So this formula that we're using is we're discounting to find PV or NPV, or it's the same thing technically.
Right now, we're actually seeking X, right? We're seeking this unknown, which is the cash flow for project B at year 3. And because we already know our crossover rate, and we know that NPV, or essentially project B minus project A over a crossover rate will mean that it's equal to 0, right? Because we know at this point that their NPV is equal to 0. So essentially right now, we're just trying to seek, we're trying to make it equal to 0 to find our X, because we know that the difference of these two at this point should be equal to 0. There should be no difference, right? Does that make sense?
Yeah, for sure. But sorry, I was just a little bit confused. This formula is, this is the PV formula, right? To find the PV formula, right?
Exactly. Yeah, exactly.
Yeah.
It's find the present value. My bad. Okay. So we're discounting our incremental cash flows to find the present value, and we know that that present value is equal to 0. That's why. Nice.
Okay, perfect. So present value is equal to 0. Okay, perfect. Thank you.
No problem. So that's a really good question, actually. So that's what we have. So with that said, now we're gonna work as a team. We found our first element. Now we can work as a team. So can somebody tell me what this is equal to? Minus 0.5 over 1.09 to the power of 0. What is that equal to? Can somebody tell me that in the chat? Okay, Ashil, you are a G. I love it. Can somebody tell me what minus 0.3 over 1.09 to the power of 1 is equal to? Somebody else in Ashil, though. It has to be a different person every time. So can somebody tell me what this is equal to? That's amazing. We're going to round it up just because it'll make it easier for us for now. Perfect. Thank you so much, Yasmin. And can somebody tell me what this is equal to? Just for fun. Somebody, of course, other than Yasmin or Ashil. Nice. Thank you, Alexander. And for this one, we're also going to round it up just for simplicity's sake. Obviously, on the exam, don't round it up. Keep it as precise as you can. And then finally, we know that we're still dealing with x minus 5 over 1.09 to the power of 3. That's amazing. Okay, cool. So, yeah, amazing. So now, essentially, if we add all of these up together, can somebody tell me what we get? If we add all of those together, what do we get? So minus 0.5 plus minus 0.28 plus 0. Amazing, Yasmin, I love it. Thank you. And then we have the classic x minus 5 over 1.09 to the power of 3. So now all that we have to do is essentially just throw our stuff at the side. So we could have 0.61 equal to x minus 5, 1.09 to the power of 3. And then can somebody tell me what our x is instead of not? Yeah, I will in 2 seconds as soon as we have our x. So what is our x? Really quickly, if you do the operation, if you bring your 1.09 to the power of 3 to the left times 0.61, then you're going to add 5. It's going to give you a number. What do y'all think? What is the number? I'm going to make y'all do a little bit of algebra. Just a little bit, tiny bit. It could be 4.21. Alexander has the right answer. Exactly. It's 5.7867. We're going to round it up to 5.79. So this is the cash flow. at year 3 for B. Amazing. Okay, really good work. So now I'm going to answer your question. Essentially, what we're saying here, okay, and the reason why the NPV, exactly, you're getting the difference, right? And we know that that difference is equal to 0 at that specific point. There should be no difference, right? Because they're at the crossover point. The present value of their cash flows should be equal to, when negated, should be equal to 0. Exactly. So you killed it. Amazing. With that said, can I ask, is everybody okay? Did this make sense? Are we feeling okay with this? Yes, no? Any questions? Now's the time. Amazing. Okay. Good. Good. Happy to hear that. This is something that there's just no other way to go about it. You're gonna see it on the exam. I mean, I've seen it every single time. Practice exams, mock exams, final exams, you know, I would definitely just have this prepared and briefed. This is for your own best interest. Okay. So with that said, let's move on to the next question. Yeah. All right. So computing EANPV, that's what we've been talking about for a little while now. So let's get a better sense of what this means. Before we go with the question, I'm just gonna, for some reason, it's never available in our notes. I'm just gonna write the formula out for you such that it's accessible and easy to go through. So EANPV could be literally written as simply as follows, okay? And you're gonna do this for every single project. By the way, could everybody see my screen really quickly? I got like a alert on my screen. Can everybody see my screen? We're good? Okay, cool. Sorry about that. Just wanted to make sure. Cool. All right, so this is how you use the EANPV formula, okay? And you do this per project. So let me just write this down. You must do this per project. Okay, so for each project, this must be done. And essentially, you take the project NPV that you figure out, then you're going to standardize it with the denominator. Okay, this is how you do it. We're going to do it for every single one of them. It's going to be beautiful. It all makes sense. All right. And the reason, really quickly, maybe you write this down or just listen carefully, is the reason why we use the EANPV formula is for two main reasons. The first one, the most important one, being that when we're dealing with mutually exclusive projects, one must use EANPV. And the nuance here, and that's the second reason, is that they typically have different years. And you're going to see this in this question. For example, project A has 2 years, whereas project C has 6 years. And for that reason, we must standardize it by using the EANPV formula. Okay, that's when you must use EANPV. In other scenarios, you could just use a classical discounting method. Okay, so with that said, let's get it going. So company XYZ is lost between 3 projects. And the idea here is that these projects are mutually exclusive, by the way. And we will go through every single one of the requirements. A requires an initial investment of $10,000 and they generate $7,000 for the coming 2 years. B requires $15K and generates $6,500 for the coming 3 years. And C requires an initial investment of $20,000 but generates $6,000 for the coming 6 years. And then we know that we need to figure out what project we're going to use, assuming a discount rate or a cost of capital or an opportunity cost of 14%. So really quickly, if you want to write this down on your paper or on your notes, when we do questions like this, the first step is, of course, identifying the different projects available to us. But then we want to find the NPV for every single project. And then we want to plug those numbers into our EANPV formula and then rank them to find the best possible project and or investment. So how we're going to go about this is we're going to do exactly that. And I'm also going to give you a trick on using your financial calculator in a fast and efficient way, such that you don't need to use the formula for discounting cash flows in order to find, the NPV for each project. All right, so let's go about that. Let's look at project A. Okay, so we have project A, and we want to find its NPV. So in order to find the NPV, you could actually use your financial calculator in a very quick and easy way. All right. So when we look at project A, we know that the initial investment is equal to 10K, CF0, and we know that we have CF1 and CF2 equal to 7,000. All right. And we obviously know that our discount rate is equal to 14%. So if you're a pro, you could already, do it on your calculator or just write it down. It's up to you. But you could actually use your financial calculator and use the function called CF. Okay, so you could use this, and you have this thing that comes out, which is CF0. CF0 stands for your initial investment. And in this case, our initial investment is equal to $10,000. And by the way, an initial investment is always negative, typically. So obviously, when we plug this in within our calculator or when we do the formula, we must use minus 10,000. So we could put in here 10,000. So as you can see, we have CF 10,000, CF0 10,000. Just make sure that it's minus, then press enter. All right. Then you could use the arrow down. So you could use this arrow to go to CO1. All right, so CO1 essentially is our cash flow for year one. All right, in this case, I already did a question before, so I have different numbers. But in this case, we know that we have 7,000. So we must plug in 7,000. We enter, then arrow down. So we have 7,000. Obviously, it's positive because that's money coming in. It's money that we're generating. Here for our frequency, I think we could all agree that our frequency is equal to 2 because we're going to have these specific cash flows for 2 years. So let's plug in 2. Make sure to press enter. So now we have the following, right? We have 2 right here. It looks like a 5 on your end, but it's 2. So we know that we have essentially cash flow 01 equal to 7,000, but because we know it's happening for 2 years, we're going to put 2 right here. Then just make sure that the other, when you go down, that they're all equal to 0. Okay, just make sure to do that. So let me just make sure that I have that as well. Give me a second. Perfect. Okay. So we have, once again, all the good stuff. So now what you could do is you could press NPV. Press NPV right here. Make sure that your interest rate is equal to 14%. So you could plug in 14%. And then once that's done, you could go arrow down. And then you could do compute, I believe. Yeah, compute to find your NPV. And that's going to give you the following NPV of 1,526. Now, obviously, it's reversed. It's kind of ghetto, but that's the idea. So in that fashion, you're able to use your financial calculator for every single one of project A, B, and C super quickly. Obviously, now I went super slowly, but this idea is that you could use this for a bunch of different questions and save the hassle of having to write it down and potentially make errors. All right. So with that said, I'm going to ask you all to find me the NPV. Oh, really? Amazing. Shit, I didn't even know that. Okay, cool. So, so for that said, I'm going to ask you all to do the NPV for every single one of these, project A, B, and C. And from there, we're going to plug it into our EANPV formula. Okay, so we have project A. We know that the NPV is equal to 1,526 times 0.62. So let's look at project B. Can somebody tell me what's the NPV? If we use the same idea on our calculator, can somebody tell me what's the NPV? Okay, that's an amazing question. So Ashiz and Justin says 90, whatchamacallit? They said essentially 9061, and that's good. We're gonna round it up. And Mohammed actually asked an amazing question, and we're actually gonna go through it together just to make it simple for everybody. So let's say you don't want to use your financial calculator, or you don't have one or anything like that. You could use the classical method, and we'll just do NPVA. So let's say we want to find NPVC. Now, just give me a second, everybody, because I'm going to show y'all how to do it by hand. So Mohammed, if you want to do it by hand, all you have to do is essentially figure out what's the initial investment for project C, and it's minus 20,000. So you would say that NPV is equal to minus 20,000, right? Over 1 plus 0.14 to the power of 0, plus, in this case, what do we have here? I believe it's 6,000. So, and Alexander, by the way, it's right here, my friend. It's right here. So you could use this. I'm gonna let you take a screenshot really quickly if you want. It's right there. So as you can see, Mohammed, is that when you want to use it by hand, and it's much longer, right? Is you have to discount every single year's cash flows. So what we did here is for year 0, we had an initial investment of minus $20,000. Then we had to look at year 1, which is $6,000. Then we had to look at year 2. Then I skipped a few years here, but you have to look at year 3, year 4, year 5, and then year 6. And then you're going to add all of them up to find your NPV. So Mohammed, you can clearly see that it's a little bit longer, but it's definitely bulletproof in that case. So let me ask y'all, what is the NPV for C? What is the NPV for C? I know some of y'all use the calculator to your advantage. Amazing. Quick fact, Mohammed, you could actually go to Concordia and ask them at the Student Center for a calculator, or you could even ask your prof for the Department of Finance to allocate a calculator for you as well. I believe there's a few options for students who lost their financial calculators. And you could also find a few for like $10, so it's not a problem. So with that said, Alicia and Naomi, amazing, you killed it. Yes, the NPV for C is indeed equal to 3,332. Okay. So now that we have our NPVs for every single year, all that is left to do is to plug this in our EANPV formula. So we're going to do this together for project A, and then I'm going to let y'all do it for project B and project C, and we're going to do it like step by step together. All right. So let's zoom in a little bit. So let's look at EANPV for project A. Now, remember, in order to do this, all you have to do is take the NPV of A and do the following. So we have 1 minus 1 plus K. Right? And for that reason, we're going to have the following. So we're going to have our NPV, which is for A, which is the following. Yeah, Kevin, what's up?
Yeah, so I'm just confused. ENPV. Never saw this formula before. What is it for?
Okay, yeah, that's a really good question. So as I said before, and I feel like if you have that question, a lot of you might have that question as well. EANPV is a formula that you probably don't even have in your notes, in your PowerPoint slides or stuff like that. For some reason, the teachers don't cover it, but it's something that you definitely do use. So essentially, you use EANPV when you're dealing with mutually exclusive projects. And this is extremely evident because a question will literally tell you, hey, we're deciding between project A, B, C, Z, whatever. They are mutually exclusive and they are operating on different timelines. So that's when you know you're using EANPV, when they are mutually exclusive projects and the projects are within different durations. And you need to use the following formula to do so. So you take the project's NPV and you divide it by essentially the annuity formula to find a standardized NPV. I would just use the EANPV formula. It literally works every single time. And if you really look well within the tutorial questions and stuff, they give you the same formula. This is the best way to go about it. It's like the clutchest one, okay? So with that said, what we're gonna do now is we're gonna have the following. So let me show you how it works. Yeah, so we have this, we're gonna have 1 plus 0.14. Now, can I ask you, all of you, what will be our n? What will be our n for 1 plus 0.14? What will be? Okay, amazing. Thank you. Amazing. So now, can somebody tell me what this gives us? What is the answer here? Am I done? No. It's slightly, there's one little mistake, Alicia. There's just one small mistake, and I think it's when you looked at 1 plus k. Alexander says 927.10. Is that true? Justine says that as well. Yes, it is true. Amazing. So that is our EANPV for project A. So we have this as our EANPV. Now, can I ask y'all to find me the EANPV for project B? What will be our EANPV for project B? I'm not going to go through the formula once again. I will ask 3 of y'all to find me the answer. Alexander is a quick one. What does it go from 1 minus to 1 plus? I'm not too sure I understand your question. Maybe you could open your mic. Oh, sorry.
Just okay.
I'm with you.
So it's 1 minus, right? Or is it? Does it swap?
My bad. Yeah. 100%.
Okay. Thank you.
Not swap. Sorry about that. This does not swap. And yeah, it's always 1 minus. Sorry, as you can see here, it's always 1 minus. Sometimes I make those small little mistakes. So EANPV for year 2, for project B, we have Justine and Alexander with 39.03. Do we all agree? Does somebody else have an answer? Or is that cool? Are we good with that? Amazing, cool. Yes, so the EANPV for project B is equal to the following. What about the EANPV for project C? What is the answer there? Justine says 856.85. You know, maybe that's true, maybe that's not. Who knows? I need 2 more people to give me an answer. 2 more people. Is it the answer? 856.85. Alexander and Alicia. Okay. One more answer. Somebody who doesn't really answer. Maybe Allison. Allison, what is the answer here? What did you get? I need one more answer. One more answer in the chat, and then we could find the final response to this question. Nice. Thank you, Naomi. So yes, the answer here is indeed 856.85. Cool. So now the last step is super simple. we found the EANPV for every single year. We have project A, so we have EANPV-A, we have EANPV-B, and we have EANPV-C. So it's really simple. To find the best project, it's like with anything else, we just need to look for the biggest number. And which one gives us the biggest number here? Is it A, B, C? Which one? Project A. And so for that reason, project A should be chosen. All right. It's as simple as that. You know, there's no heavy lifting there. What's good, Curry? How can I help you?
Yeah, actually, to be honest, like when I take a look into a question like this, I first of all, I would go like maybe with the IRR and try to maybe have that graph where, you know, the graph that you actually drew earlier, and see which one is more profitable depending on IRR and NPV, right? This is how I would have done it. Is that okay too?
So that's actually not okay. And that's a really good indication as well. The reason here, and I need this to be super clear to everybody here. If you see this, this is like, you know, it's literally the golden rule. If you see mutually exclusive, all right, if you see mutually exclusive, you cannot use a simple IR method, a simple discounting method, you cannot, all right? When you're looking at mutually exclusive, you must use EANPV. There's just no other way to go about it. It's the actual only way to do so, okay? You must use EANPV. It's the only way to standardize our cash flows here. It's our only way to understand the NPV, like in a correct way. So once again, if you see mutually exclusive, just go with EANPV, the simplest and the most accurate way. All right. Everybody, I need that to be super clear. Okay. It's the only thing that you want to use. You see this, you must use EANPV. Perfect. So what time is it now? Yeah, I think we could do one more question and then we'll take a break. Yeah, we'll do one more question, then we'll take a break. The next question is it's a heavy lifter. It's fun. It's gonna really invoke a lot of the different things we understand about NPV and the crossover rate and all that good stuff. So after this question, we're gonna take a small break. It's really fun though. I like it a lot. Yep, there you go. Sorry, I'm just trying to zoom out. It's not letting me zoom out. There you go. Sorry about that. So we have an amazing question. I had it on my final when I took Comp 308. Honestly, it really stumped me. I guess I wasn't as prepared as I thought I was, but it's actually super straightforward when you understand what to apply. Okay, you don't need to go as granular as I will right now. I'm really going to try to break it down as much as I can, such that everybody in tonight's crash course understands what to do. Okay, but you do not need to go as in depth. Really choose the parts that work the best for you, and maybe try to like play with the numbers a little bit to see what's the best case. Like if you want to practice again, you know, on the weekend or something. So Nike has the following cash flows for 2 mutually exclusive projects. Okay, so we have 2 mutually exclusive projects. Already, this looks really similar to our crossover rate question. You know, the same like type of like framework. We have project A, we have project B. Like we've seen this before, okay? So that's the first indication. We've seen this before. It's not too foreign. So we've estimated that the IRR for project A is equal to 15.86. You love to see it. You love to hear it. It's amazing. You also estimated that the IRR for project B is 14.1%. Now, just FYI, you could totally calculate it yourself by just plugging it in within your calculator or doing it by hand, but they're giving you the IRR already, okay? Like it's literally given to you, it's simple. You don't need to calculate it. The payback period for project B, for project A is 2 years, while the payback period for project B is 3.2 years. Okay, not bad. Thank you. Like to know it. So when is project B more lucrative than project A? That is, over what range of discount rate does project B have a higher NPV than project A? Okay, so what's more lucrative? Okay, so let me say this one more time. Over what range, so at what like range of discount rates does project B have a higher NPV than project A? So this is a super fun question, and I kind of geek out on the math. So you'll be able to really understand how we break this down. So right now, what's really important, and I'll put it in red, is that we understand that we're dealing with two mutually exclusive projects. That's the first buzzword, okay? You understand that we have the similar like viewpoint package of the question of the questions that are like dealing with, crossover rates, incremental cash flows. So when you see this, you really start to see, okay, boom, we're dealing with incremental cash flows, crossover rates, something of that nature. So you should think about the first tools that we use there. And then you also have your IRR. It's the good stuff. Not bad. It's fun. Okay. So now what we're going to do is we're going to try to plot this onto a graph to make sense of what we're dealing with. Okay. The first thing that I would do if I were you, actually, we're going to do our graph first, and then we're going to see what is required on our end. Okay. So as per usual, we're going to have our K as our horizontal axis, and we're going to have our NPV as our vertical axis. Okay. And essentially, what we're going to try to do now is plot our crossover rate for us, just to make it really, really, really easy for us. Okay. We're going to try to do that right now. Okay. We're going to try to plot the different elements that we know. So really quickly on the chat, can you tell me, just for fun, what are different points that we could maybe put on our graph already? Like, what are things that maybe you would want to put on our graph? Like things that we could plug in based on the information they provided. So Alexander says 15.86, he says 14.1. And does somebody else have different ideas, or do you all agree with Alexander? Maybe like one or two people, just for fun. I want to really get your head going. So Alexander says that we could maybe plug in 15.86 and 14.1 on the graph. Does anybody else agree? Do you have any other ideas of what we could try to plug in into our graph? One more person, just for fun. Okay, Yasmin, that's an amazing point. Crossover rates, I love that. And then Justine says cash flows. Cash flows are going to come in handy. Mohammed says the equation that use IRR and payback period. So that I like the ideas. We're doing really well. Okay. So the first thing that I would probably do is set up our different IRRs, right? Can we all agree that an IRR is it's a discount rate? It just has really special discount rate. So what we're going to do is we're going to plug those into our graph. So we have two different IRRs. We have 15.86 and we have 14.1. So we're going to just plug them in right here. So we're going to have 15.86. And I guess we're going to put our 14.1 right here. Do y'all agree that maybe we would want to add our crossover rate on our horizontal axis? Yes or no? What do y'all think? Maybe we should try to find our crossover rate. Does somebody agree with that? I don't know. I know I'm taking my time. I just want to make it really step by step. So yeah. So we would want to find our crossover rate. Essentially, what we're trying to do right now is plot all of our different interest rates on our K line, on our horizontal axis. Okay. So the first thing we're going to do after that is find our incremental cash flows, right? This should be a bell that kind of pops off. So we're going to find our incremental cash flows from year to year, and that's going to allow us to find our crossover rate. Cool. So This is our incremental cash flows. Can somebody tell me what's our incremental cash flow if we look at, for example, B minus A for year 0? What's our incremental cash flow for year 0? Thank you so much. Amazing. So we have $0 here. What about year 1? What's our incremental cash flow at year 1? Minus 30,000. I like that. What about year 2? Thank you so much, Elisa. 30K, yeah. What about year 2? What's our incremental cash flow at year 2? Is it 5? Is it $1 million? Is it 0? Is it 6? I don't know. What is it at year 2? Thank you, Justine. Yes. What about year 3? Once again, simple, nice. What about year 4? 40,000. Yep, 40,000. Amazing. Cool. So now we have our incremental cash flows for every year. And what we're going to do now is we're just going to try to find essentially what's our crossover rate. Okay. So we could actually just do it on the side here to make it simple for us. So we know that our crossover rate is at the point at which NPV for both project A and project B will be equal to the same thing. So the difference should be equal to 0. So for that reason, we're going to have 0 equals, all right, 30K over 1 plus K to the power of what? To the power of 1, 2, 3, 4, 5. What's our exponent here? Is it 1, 2, 3, 4, 5? What am I going to put here? For 30,000. For 30,000. You're up there, but yeah, no, for 30,000. There you go. Amazing. Nice. Good. And then we're going to have 40K. And then what's my exponent for 40,000? There you go. Now it's 4. Hell yeah. Okay, cool. So essentially now what we have is something super interesting. We're going to try to solve for K. So we're going to simplify this step by step together. I'm going to make this kind of quick. So we have minus 30K over 1 plus K. And here we have 40K over 1 plus K to the power of 4. And the next step essentially is that we're going to group all of these together. So for example, this is a trick that I would probably like make it easy for all of us to have, is that when you have an algebraic formula like this, you could actually simplify it as follows. You can simplify it just like this. You don't even need to try to understand why. You could literally just have it as a golden rule for yourself. So you could have 1 plus K to the power of 4, which remains your denominator. Then here you could have essentially 40 grand times 1 plus K. All right. And then you could have, I could do that. It's up to you. If I ask somebody here in the chat, Justine, yes, amazing. Is it, what's our K here? If I ask somebody to just tell me really quickly, Justine says 10.064. You could use a calculator like mine to do it. I'm gonna ask one more person. Okay, amazing, yes. So our discount rate is equal to 10.064%. So this is our crossover rate, okay? This is our crossover rate. So now what you would want to do, we'll keep it in green. What you will want to do is add this to our graph. And there are steps to take here. We could put it here, for example. So now we have our crossover rate. So we know that this is IRR. You find your K just by solving for X here. I'm gonna be totally honest with y'all. When I had my exam, I have this calculator that allows you to solve like equations like that. So I just plug it in. But you could try to break it down in an algebraic fashion to solve for K. There's different ways of going about it. You could essentially just put your denominator to your numerator as like -4. You could also try to group them up and then essentially times 40k by 1 plus k, and then bring the denominator to the left-hand side. You could really try to break this down in a bunch of different ways, but quite frankly, you could just kind of use this as your biggest basis. So when you find k, which is 10.064, you would plug it in to your horizontal axis. And just for reference here, once again, this is our crossover rate. This is essentially for project A, it's equal to 40.1. So we have IRB, we have IRA. Okay. So we have all these different points. Now, the last and easy step for y'all, and this is really the best way to go about it, the last and easiest step for y'all is to just find the NPV for project A and project B. The reason why we want to find our NPV is because we understand that our NPV, sorry about that, with my voice crack, that your NPV essentially at a specific point when k is equal to 0, I guess I could break it down in an easier way. Right now, what we did is we found essentially all the points that we'd want to add to our horizontal axis, right? Which was our K, our crossover rate, our IRR for project B, and our IRR for project A. That was the only heavy lifting that we had to do. However, now we want to find essentially our points on our vertical axis. So essentially our points are NPV for project A and for project B. However, this is actually really, really easy for us to do. What I want y'all to remember right here is that at this point, our K is equal to 0. Do we all agree that on our vertical axis, any point here is when our K is equal to 0? Any point like this, any point like this, any point like this. Can we all agree to that? That our K is equal to 0 if it's on the vertical axis? Yeah, I need like 2 more yeses. Okay, amazing. So what we could do is essentially, we want to find the points for project A and the points for project B that are touching our vertical axis. So in order to do that, all you have to do is simply add up all of these numbers together. When you add up all of these numbers together, you will get your point on the vertical axis for project A and project B. And the reason why you could add up all of them up together is because we're essentially discounting them by 1, right? We're discounting them by here, 1 plus 0% to the power of 0, 1 plus 0% to the power of 1, 1 plus 0% to the power of 2, 1 plus 0% to the power of 3, then 1 plus 0% to the power of 4. And because we're discounting them by 0%, essentially, we're just keeping them as their whole number. So if you could tell me, what is the sum of our cash flows from year 0 to year 4 for project A? Sorry about that. I'm losing my voice a little bit. Amazing. So yeah, we have 30,000 for project A. And what would it be for essentially project B, 40,000. Thank you, Justine. So we have 30,000 here. We have 40,000 here. Does everybody understand in 2 seconds why we do this? So we have right here, I guess right here. So it was 30K for project A, then project B. So now we have all of our points. We have essentially the value of the NPV if we use a discount rate of 0%. And then we also have our different points along the line, okay? So now it's as simple as doing the following step. So what we're gonna do is we're gonna essentially link project B's NPV at discount rate 0 to its IRR right here. And we're gonna do the same for this one, project A. And we're just gonna move this to be a little bit more accurate to like here. There you go. Give me a second. Okay, so essentially, the reason why we're doing all this, and I know it took some time, but the reason why we're doing all this is because we literally get to answer the question. Because we understand that on our vertical axis is where we have, okay? On our vertical axis is where we have essentially our NPV. So what we're seeing here is that from this point on, up until our crossover rate, right? And from, let's say, this point on, we can clearly and fast understand that NPV for project B is equal to NPV for project A. We could also understand that for this line, NPV A is bigger than NPV B. So what this graph showcases, it literally tells you, like, to no fault, for which part of our graph does the NPV for project B is bigger than the NPV for project A. And it tells you after that, for which part of your graph is the NPV for project A bigger than NPV for project B. So in this section, we clearly see that from 0% to 10.064, we know that project B has a better NPV than project A. Therefore, you would suggest to take project B. And we know that from 10.064% to 15.86%, we should accept project A. So with that said, essentially what we get to see here is it literally answers our question. And our question was really clear. When is project B more lucrative than project A? So can somebody tell me in the chat, when is project B more lucrative than project A? From just our graph that we just plugged in here. Just type it in. Exactly. Exactly, 100%. Asha is totally correct, because we know that from this section on to this section, we know that project B is bigger than project A. And then let me ask you the next question. When is project A better than project B? If you just put it in the chat, when is project A better than project B? Somebody else other than Ashid. When is project A better than project B? Amazing. There you go. Good. So now I'm sure you have a lot of questions. So Kareem, what is up? What's up? How can I help you?
Yes, so just making sure, isn't this question mutually exclusive projects?
Yeah, exactly. But essentially, when you're looking at like mutually exclusive projects and they're asking you about the crossover rate or IRRs, or like what's the best range of projects, you could definitely use incremental cash flows. The idea here is that we're not like really asking you which project you should choose necessarily. We're more so asking you, based on the IRR and based on the crossover rate, what is the best range? And if you look at the previous question, we had multiple projects, right? We had A, B, and C with different years, right? And in this case, in the question that we just did, we had the same amount of years for project A and project B. So it made it simpler for us. So the idea here is that, to make it quickly, is that if you're dealing with two projects that are mutually exclusive with the same timeline, and that they give you this type of format with project A and project B, like right here, it's really obvious that you need to look at incremental cash flows, and that you need to look at either the crossover rate or a missing cash flow in that nature, okay? And Justine says, and if they ask in year instead of range of discount rate, so like, do you mean like for what years they're better? Well, if they ask you for what year that is better, I mean, listen, I can be hard pressed to believe that they would do so. It's going to be extremely difficult for even a PhD teacher to do so. So they're really going to ask you, when is the range of discount rates that are really like available to you? Maybe what they could do, for example, is they could ask you like the payback period, but that would be like a 12-minute question rather than a 3-minute question. So Justin, I wouldn't worry about that too much. Okay, I would not worry about that too much. And then to solve for K, essentially, you just want to use this formula right here, right? And then you just want to break it down into easy steps to find to find X. And there are different ways to go about it. Maybe you could try to break it down a few times, but you'll definitely get to X. The way I used to do it was just by plugging it in into my calculator and it would solve it for me. But if you don't have that feature, I definitely do like either get a calculator like that or sort of like just sit down and break it down or put it through like your math solver or something of that nature. But grosso modo, like overall, does this make sense? Do we understand why we're using this setup? And do we understand like the flow of it? Like, does this make sense? Are we all okay with this? I know we're kind of tired. Everybody wants a break, but do we understand what this is all about? Cool. So I got a few yeses. I'm happy about that. Amazing. So just for a quick summary, when you have a question that discusses range, it's kind of likely that you'll see this on the exam. I've seen it quite a few times. Just really understand that you want to plot in your IRRs, find a crossover rate such that you have all of the different Ks you need, and then you want to find your NPV. Takes 2 seconds, and then you're just going to plot the lines. And then once you plot the lines, it makes it obvious to you what range is better than the other. Simple like that. Okay. So with that said, we're going to do a classic little break just to kind of recapture our time here. And we'll meet up in 10 minutes. So we'll meet up at 7:55. Okay. 7:55 p.m. And we'll get back into it together. Yeah, Elisa, 100%. Like it's literally, you could even do a proof if you want. If you discount all of them by 0%, it'll be equal to the same amount. So 100K discounted by 0% at year 0 is equal to 100 grand. $20,000 discounted by 0% at like for 3 years is equal to 20K. So all you have to do is just sum these up together. So 100 grand, well, minus 100 grand plus 60 grand plus 40 grand plus 20 grand plus 10 grand is equal to 30 grand. All right. No problem. So with that said, 7:55 p.m., go get yourself some water, some coffee, come back energized, and we're going to do the last set of questions, okay? All right. So 7:55, we're back. We're energized, we're ready. So yeah, we're going to go through a few evaluating capital budgeting questions. So this is more so related to WACC, incremental cash flows, crossover rates, kind of like bullet questions that you kind of want to be prepared for on the exam. So we'll go through them. We'll break them down. I believe we have a few. I don't know if we'll go totally through them. We're going to see. Let's see how we allocate our time. We do have an hour-ish, so let's see how it goes. So we'll go for A, B, and C. That's what we're going to aim for as of right now. Anyways, so same idea. We have the following questions with following prompts. I'm going to ask y'all to participate, to tell me what you think the answer is, and from there we'll see if you're correct. Okay, so you're considering an investment at a price of $190,000, and it's after tax. Net cash flows will increase by $30,000 per year. Okay. And it remains at this level forever. If the appropriate cost of capital is 15%, what is the NPV? And by the way, quick disclaimer, this part right here, the idea of per year, it's actually kind of like cap. It's not really that. It's more so $30,000 will be the cash flow every year. Okay. So it's not going to be 30,000, 60,000, 90,000. It's $30,000 for all of the years of the investment forever. Okay. So it's not a growing perpetuity. It's just a perpetuity. Okay. So with that said, what is the NPV of this project? What is the NPV of this project? I need 2 people to answer, to give me an answer, and then we'll go about it. Maybe Alexander's right. I don't know. Maybe. Is it $10,000? Who knows? Maybe it is. No idea. Exactly. No idea. So I need one more person with an answer, and we'll move forward. One more person. 10,000. Amazing. Thank you. Okay. So yeah, the answer here is totally $10,000. So once again, the idea of NPV, it's the idea of initial investment plus cash flows. In this case, we know that our NPV will be equal to minus 190,000. Then we have this plus our perpetuity, which is of $30,000 over 0.15. And this means that our NPV is equal to 190 grand plus 200,000, I believe, plus 200,000. And for that reason, our NPV is equal to $10,000. Simple and easy. Does everybody understand this? I need to see 4 yeses in the chat really quickly so we can move on to the next one. Does everybody understand this? Was this clear? Yes, sir. Okay, good. Amazing. Cool. So with that, let's move on to the next one. Similar idea in a sense. So we have project A. It requires a $1,290 initial investment. Oh, this one's interesting. And returns $600 per year. Okay, so that's for project A. Then we have project B, which requires a $2,400 initial investment and returns $700 per year forever. We want to know, what is the crossover point? Okay, what is the crossover point? This one's really, really interesting. It's a fun one, kind of quirky, to be completely honest with you, but we'll play along. All right. So what do y'all think is the crossover point? What is the crossover point? I'll zoom in a little bit. We have Alexander Lee with 8.95%. Okay. And maybe that's true. Maybe that's not. Who knows yet? No idea. So yeah, who knows? You know, I would like 2 more answers. Two more answers. 2 more answers. Not sure either. Okay, we have 8.95, 8.95. So these are all the right answers. And for this question, you could go about it in the way that we typically do it, right? So the classic, we have the project. So we have project A, then we have project B. Then essentially we do our classic B minus A. You could definitely go about it like that. At the crossover rate, their NPVs are equal. You could definitely go about it like this in the sense that you have, so 1290, then you have, whoops. Then you have their perpetuity over the crossover rate, or you could essentially just do this as well, over 700. Then you would find the change. But there's actually a really easy way to go about this. And it's actually as simple as the following. So to find the crossover point of a question like this, you could actually break it down just as follows. You could break it down by simply doing the following. So you could do K, which is your crossover point, is equal to the difference in cash flows, perpetual cash flows, over the difference in initial investment. So can somebody tell me what's the difference in our initial investment for project A and project B? If we do B minus A, what is the difference between B minus A? Hell yeah. Well, yeah, we could keep it positive as well. We could just kind of like do B minus A. So we'll keep it positive as follows. And what about our perpetuities, like our cash flows coming in forever? What's the difference between 700 and 600? 700 minus 600. What is the answer there? Nice. Exactly. So this right here is, once again, it's also what we could call the change, right? Or just like the difference, right? The difference there. Although delta is more so the change, but we're just going to call it the difference for our sake and purposes. So for that reason, this would mean that KC could be equal to, when we have something as quick and easy as this, KC could be equal to the change in our cash flows, which is 100, over the following. And what would be KC, or just our crossover point in that case? 100 divided by 1,117, and that's exactly 0.0895. And that's exactly 8.95%. And this question is really interesting. And I'm not going to lie, the first time I had to deal with this question back in my day, I definitely went about it with the classic incremental cash flow analysis. But this is the best way to go about it quickly if you have a bullet type of question like this, in which you are required to find your crossover point, but you're only dealing with a initial investment with a perpetuity, right? So what you would do is really as simple as this, just taking the change in the perpetuity payments over the change or difference in your initial investment. And then you'll be able to find your crossover point in a second. This is the easiest way to go about it and the quickest way to go about it, all right? So now the next question that I would like to go through, and really quickly as well, is so that way it can only work if we only have 1 year of return after the initial investment. It's more so, Acosta, if we're dealing with a perpetuity. If you're dealing with like regular set cash flows, you can definitely just go with our classical approach. But in this case, since we have perpetuities, it's as easy as just putting it over our initial investment, the difference that is. And like that, you'll be able to find the crossover point. This is typically when we're dealing with perpetuities. So more so the idea, as you can see here, sorry, if we go with like something in purple, this idea right here, forever aspect. When you have a forever aspect and you're dealing with perpetuity, you could actually use this formula right here. Okay. You could really just go with this. All right. So with that said, let's go into C. Let's check this out. So you're considering a project with an initial cost of 70,000, no problem, of 70,189, with annual cash inflows of $17,000, $17,304 per year forever. Nice, we have another perpetuity. So what is the discount rate that will produce a profitability index of 4.0? Okay, let me see, is that correct? Let me see really quickly. So we want to know what is the discount rate, by the way, discount rate. So Justine has 8.21, Alexander has 6.16. Are they correct? Who is more correct? And I'll give you all like a quick tip right here before we begin, really quickly. So that's a good one. The quick idea, really quickly, when we're looking at profitability index, I'll start you off with this, is that we're looking at profitability index. And it's really just the present value of essentially our inflows over the present value of our outflows. Okay. So right now, what we're going to do is we're going to try to figure out, well, what are we missing here? Do we know what our outflows are? And do we know what our inflows are? So before we continue, Alexander said 6.16%. is the K we need to produce a profitability index of 4. Ashaya says 6.16%. Can I have one more person with an answer just for fun? Is it 8.2? Is it 6.1? Is it 7.8? Is it 4.84? What is the answer? One more person before we continue. Nice. Okay, good. So you are correct. The answer is 6.16%. And the way to go about it is really we're dealing with the classic game of unknowns. So over here, we know our PI, which is 4. We know our outflow, but we're not too sure about our inflows. That's where we're going to find our K. Okay, so like that, we know that our profitability index is equal to 4.0. And we know that our outflows, what are our outflows really quickly in this problem? What are our outflows? Is it 4? Is it 1 million? Is it 70,000? Is it 60,000? What are our outflows? What is our denominator? Nice, thank you. So yeah, our outflows are equal to 70,189. However, our inflows, well, the present value of our inflows, because we know we're dealing with a perpetuity, will be as easy as the following. So it'll be just a formula of our perpetuity, like this. And then we just have to derive for our K. And like that, we're going to be able to figure out that K is actually equal to, or if you want to simplify it further, we could do it as follows. You could just plug it into your calculator. It's really up to you. And this would give us a K of 6.16%. Really as simple as that. Are we all okay with this? No pun intended. Are we all good with this? Does this make sense? For this one, yeah. Are we good with this one? Is this easy? Is this cool? Okay, perfect. Nice. So with that said, let's check. We have an hour, 50 minutes. Maybe we would want to go towards the next question. Let me see. Okay. We're gonna just, before we do this big question right here, which is about computing NPV based on the capital budgeting. So we're looking really at the classical big question that you may see on your exam, which deals with chapter 14. I think that maybe we could look at a quick question on WACC, on a weighted average cost of capital and stuff of that nature, just to be sure that you know how to do it really quickly. So we're just going to go here before we go into that big question. We're going to look at A, B, we look at these two questions, just about WACC, about debt to equity ratios, because it's maybe likely that you'll see it on your exam. Because we only have about 50 minutes to 60 minutes left, I want to just really prioritize this as well as this question, okay? So with that said, we have the following, all right? We have the following question, and we're asking you, a firm's debt to equity ratio is 1.2. This actually comes from an exam. So a firm's debt to equity ratio is called 1.2. The before tax cost of debt is 7%. The risk-free rate is 3%. Beta is 1.2. The market return is 8%. The tax rate is 40%. What is the firm's WACC? And this one's a heavy lifter, right? You need to apply some sort of like small logic to be able to find the answer. So with that said, I want to give y'all maybe who knows? I want to give y'all like a minute or two to find the answer here. What do you think WACC is all about? What do y'all think our WACC is in this scenario? I'll give y'all a minute, and if we don't have an answer, we'll be able to kind of just do it together. What do y'all think WACC is? Or what do y'all think is the first step, if anything? When you see a question like this, what would be our first step? You see a question like this, what would be our first step? Or what do you think the answer is? I'll give you all about a minute to go about it. Something that you probably will see on your exam. It's good to know how to deal with it. Give you about 30 seconds. On to something. Okay, thank you. I like that shit. Okay, so yeah, the first thing that we want to be able to play with here is that we need to understand what is WACC. WACC, once again, is the weighted average cost of capital. So essentially, I'll write it down just for us to be on the same page. And it's going to give us the steps to follow when it comes to actually building out our formula and building out our next steps. So WACC is really honestly equal to debt over value times the cost of debt, call it KD or cost KB. Okay, this is actually a good question. And this, we could allocate our time differently. By the way, in all the previous semesters, WACC was included into the final exam. Jack pointed out in the chat that WACC may not be included. So chapter 20 may not be included into the final exam. Is this correct? Did most of y'all cover WACC in your studies? Was chapter 20 included in the outline for exactly? Yeah. So maybe a few people could point it out. Is WACC included in the final? Was WACC covered in your classes? Yes or no? Chapter 20. Alexander says yes. Jack says otherwise. Katerino says yes. Maybe like 2 more people could weigh in. Okay, 6 questions. Okay, likely 6 questions on it. Okay, cool. So we're gonna cover WACC. You know, we're gonna go a little bit on this chapter 20 stuff. Okay, good stuff. Okay, so this is major. Yeah, 100%. So yeah, when we look at WACC, we're gonna look at debt over value of the firm or value of whatever, times KD times 1 minus tax. All right. Plus essentially equity over value times the cost of capital. You could just call it K. It's really up to you. All right. So this is how you find WACC. This is a simple, really numbed down version to go about it. But in this case, we know that there are some elements that are missing. Okay. Because in the question, we're only given debt to equity. And we're also not given our actual cost of capital or our K. So the first thing that I would like to do is perhaps maybe let's find our K. Let's try to figure that out. All right. So in order to find our K, so finding our cost of equity, which is also known as our K. All right, so to find our cost of equity, we could actually just use CAPM. And remember that CAPM essentially says that K is equal to RF plus beta ERM minus RF. All right, that's what we remember from exam 2. So really quickly, can somebody tell me what would be our K if we use the following function? So our risk-free rate, I believe, is 0.3. You have beta of 1.2. Exactly. Nice. Then the following. Okay, so our K is equal to 9%. We could all agree that it's equal to 9%. Now the next step is fairly straightforward. So now we want to be able to find our debt to value and our equity to value. So that's step B. We're going to use a different color. We feel cute right now. So B is finding our proportions, finding debt and equity ratios. So this is something crucial, and I need all of you to kind of really understand this and kind of stick with me with this one. So in the question, we are given our debt to equity ratio. Can we all agree that our debt to equity ratio is not the same thing as our debt to value ratio? I think we could all agree to that point. So what we need to do now is we need to figure out a way to get our debt to equity ratio to give us our debt to value ratio and or our equity to value ratio. Okay, so in order to do this, we need to understand the precedent. The precedent is as follows. We know for sure that if we add debt to value plus E to or equity to value, we're going to get 1, okay? Because we're dealing with percentages. So we know for sure that debt over value plus equity over value is equal to 1. All right. We all know that debt over value plus equity over value is equal to 1. Why? Is because we're dealing with proportions. We're dealing with weights of a total amount. We're like kind of dealing, if you want, with a pie. Whoops, that's a terrible circle. If you want, we're kind of dealing with a pie. And we're trying to see what portion represents equity and what portion represents debt, right? And the total pie is equal to 1, or you could call it 100%. If preferred shares aren't mentioned, we could assume that equity is both preferred and common shares. That's an amazing question. And actually, preferred shares, for the scope of Comp 308 and all courses you're going to take actually, like FINA 395 and FINA 385, preferred shares are actually considered to be really similar to debt. They're actually not considered to be like equity because they follow a specific structure that's similar to debt. But for this question, for this exam, do not worry about it. Just really look at equity and debt. And for the large part of your questions, you're going to be dealing just simply with, K or shares and debt as just being like, YTM or something like that. So preferred shares, actually don't worry about it too much, but preferred shares are kind of more so considered as being like debt. So that's why when we look at WACC, we look at our formula above, we would actually add like a portion just for preferred shares. But it's not something that you're going to really see on your exam eyes. I'd be very doubtful that you'd see that, okay? So with that said, so we know that we know that debt to value plus equity to value gives us 1. Why? Is because we're kind of looking at a pie. We're looking at this large pie and we're trying to see which piece of the pie is given to equity and which piece of the pie is given to debt, right? So that's, the analogy that I perhaps want you to kind of internalize here. Okay, so we could put this here for now. Amazing. So now we know this. And we could write this down in a better way. So we could say that D over V plus E over V is equal to 1. right? That's what we know. So now that we understand this, we essentially want to just use the information provided to us that our debt to equity ratio is 1.2, and then find our resulting DV and EV. So how do we go about this? We could go about it in the following ways. So what we're actually telling you is we're telling you that your debt to equity ratio, right, which is D over E, we're telling you that that's equal to 1.2. However, we could simplify this in a really nice way. We could say, because D over E is equal to 1.2, we could actually argue that D is equal to 1.2 E, all right? Because we know that D divided by E is equal to 1.2, we could say that 1.2 times E is equal to D, all right? That's the idea here. So when we look at our beautiful formula right here, we could just plug in our D as being simply 1.2 E, all right? You'll see what I mean in just a second, as 1.2 E, all right? So now that we know this leads us to the following point. So we could repurpose our formula as follows. We could say that 1.2 E over V plus E over V will give us 1, okay? So now you could actually just make it as simple as solving for X, right? Because we know that 1.2X plus X is equal to 1, then you could solve for X. So knowing this, if I'd have to ask you, what would be our equity to value? What would be E over V? What would be E over V? Right? What would be our X in this case? What would be E over V? If you'd have to apply some quick math. We have this algebraic function. We're trying to figure out what is E over V now. It's simply plugging it in. What is our E over V? I need 2 people to write it in the chat. And tell me if you're lost. Tell me if this doesn't make sense. We could definitely break it down into different pieces. Yeah, what's up, Kareem?
Yeah, I don't know if I'm right or wrong. Actually, how I do it is when I see, if you maybe want to scroll up so I can actually scroll up to the question. So when it says over here, debt to equity ratio is 1.2, it's technically 1.2 debt is equal to like 1 equity, right? So what I do usually is 1.2 plus 1 gives me 2.2. And then this is where I actually do the weights, right? So 1.1 debt divided by the V, which is 2.2, gives me, if I'm not wrong, I think it was 0.54, something like that. And then obviously, then I do 1 minus this, gives me the equity, and I have the weight. This is usually how I do it. Does it work?
That actually works 100%. It's actually repurposing what we just did, just into like a streamlined version. It's like not broken down step by step. So what Kareem just said is a really good way, once again, to find the total value. And he said that, well, that is equal to 1.2. So he divided that by V, which gave him the weight. And the same thing, the same step could be applied here. And as Justine and Costa said in the chat, and Ashil said in the chat, from there, when we break down our formula, like the way we did it, by the way, Kareem, it works. By the way we did it, we actually get to having our EV equal to 0.45, right? Essentially, this is, as Kareem said, just to make it simpler for everybody too, this is our weight for E, okay? This is our weight for E. You could call it equity to value. You could call it a bunch of different things, but the idea here is that the proportion allocated to equity is 45%. And by definition, if our weight for equity is equal to 45.45%, what is our weight for debt? Can somebody apply the quick math here for me? What is the proportion for debt. If we know that the proportion for equity is 45%, 0.45, what is D over V? If E over V is 0.4545, what is the answer? Somebody write in the chat. If E over V is equal to 0.4545, thank you, Alexander. Yes. So yeah, 100%. D over V would essentially just be this. And as Kareem said, for those who like that approach better, you could also just say 1 minus weight E. And for that reason, D over V will be equal to, I guess I'll write it somewhere else. D over V be equal to 0.5454. All right, so that's how you find your debt to value and your equity to value. And if you like Kareem's approach a little bit better, that's how you find WE, so weight for equity, and WD, so weight for debt. Okay, so now all that we have to do, because we found all the elements we were missing, is plug those numbers in within our formula. So how would this look for us? This would look as simple as this. I'm just gonna zoom in a little bit. Perfect. So WACC would be equal to essentially 0.5454 times 1 minus, I believe it was 0.4, times 0.7, right, plus 0.4545 times our cost of equity. And that's going to give us what value? This is how we found our WACC. And what value would this give us if we put all of these elements together? What value? What would be our WACC? What would be our WACC? If we do first bucket plus the second bucket. Okay, Justine has an answer. I need everybody to give it a shot. At least 3 people to give it a shot. Perfect, amazing. So yes, the answer here is definitely 6.38%. Exactly. So this is something that not only will you see in Comp 308, you're also going to see it in your first exam in FINA 395. You also may see this in FINA 385. This is actually a reoccurring theme, this idea of dealing with debt to equity ratios. It's not very difficult, but you need to understand the steps to take. This is definitely something that I would like you to add to your formula sheet or your cheat sheet. The idea of how do I convert my debt to equity ratio to a debt to value and equity to value. Really, really important because it's going to allow you to apply it within your WACC formula, which we had at the top. So really quickly, before we move to our big capital budgeting question, which really covers everything you'll need to learn and know, do you have any questions or any questions or like inquiries with this? Like, was this straightforward? Do we understand this question? Are we happy? Okay, it's amazing. So how did we get 0.09? So essentially, in order to get 0.09, we use CAPM. And for CAPM, we understand that we need to allocate the SML, right? We're using the SML line. And the SML line essentially says that RF plus beta times the market risk premium, so ERM minus RF. And then when you allocate all of that, when you plug it in, you actually get 9% as your answer. So it may have been like a small miscalculation on your end, but really the idea is that K, our cost of equity, will be found by using CAPM in this case, because they gave us beta, they gave us a risk-free rate, and they gave us a market return. Perfect. Okay. So now this is the most comprehensive portion of the course tonight. It's really understanding how to go about capital budgeting questions. This differs year to year. Some years they decide to not do a really big question, but some other years they decide to kind of be weird and go hard. So this question is really like the best of both worlds. It tells you what you need to do step by step, literally portion by portion. So understanding this will be really super crucial to your success, in my sincere and honest opinion. So what we're going to do now is we're going to go through all the different buckets applied to NPV capital budgeting / questions, okay? So let's go about it. So we have this company, Magma Inc. And actually, before we begin, maybe I could tell you about the different things you want to kind of have your eye to when you're dealing with. Yeah, sure, no problem, Justine. Just send me a message on Facebook such I can remember to allocate it within our solutions on our member area. So with that said, what I'd like to do before, and we may go over 9 o'clock just because these questions kind of are long and I want to break it down into simple steps. But when we break down these questions, we typically deal with, if I'm not mistaken, like 6 elements that you really want to master, okay? And we're going to try to just allocate those elements into segments, all right? So the first typical element that you deal with when doing capital budgeting NPV questions is our initial cash outflow, okay? So that's the first thing that you probably want to look out for, all right? And right now what we're going to do is we're just going to try to define all these different elements, and then we're going to try to find them within our question, okay? So when you're looking at an initial cash outflow, you're really looking at a keyword. You're searching for search keyword initial investment, because that's really what we call our initial cash outflow. It's your initial investment. So you really want to seek that out and you want to highlight it, okay? Then the second idea is you want to look for any terms or any ideas about your contribution to net working capital, okay? Search for initial contribution. And honestly, I would be surprised if you'd have that on the exam, but still it's important to know. To net working capital, okay? So typically, just to make this clear, when you're dealing with net working capital, you're typically looking at what we call literally working capital. And working capital is typically your current assets and your current liabilities, okay? So maybe remember that working capital refers to current assets and current liabilities, right? And then you may also look at opportunity cost, which deals with your literally not sunk costs, but things that you're missing out on. And people may look at that within your initial cash flows, okay? So you may also look at right? So that's typically what you look into when we're discussing initial cash outflow. It's really the first thing that you want to get out the way. It makes it really simple for you when doing these types of questions. It's as simple as that, okay? Then you want to look at your operating cash flows, or just the cash flows you're going to be making within the project or within the investment, okay? So the second bucket is dealing with operating cash flows. And the reason why I'm color coding everything is just because when you're going to review this question and when we're going to segment our different parts of this question throughout the prompt, we'll be able to color code them and make sense of it in a better way. This is actually a really good question, Costa. Realistically, you're going to have about 3 questions on capital budgeting. So what we're doing right now, you should expect about 1 or 2 questions on WACC. Then I would expect about 2 or 3 questions on just like decision things. So IRR, NPV, payback period. So about 7 to 9 questions related to post midterm 2. Then you should expect a lot of questions on midterm 1. From my experience, you typically have about 7 to 9 questions on that as well. Really dealing with this idea of your timelines, dealing with growing annuities, normal annuities, annuities due, perpetuities. You really want to be able to be on your toes, and there are typically going to be some harder questions. Then about a fair amount will be allocated as well to exam 2. Not so much an emphasis on a specific part. They kind of really diversify in a good way, but they don't have too many easy questions that you had in midterm 2. It's more so on the mathematical approach and a little bit of like market efficiency. So it's really kind of well diversified per chapter, per exam topic. Yeah. Typically it's 30 questions, but it may also be 32. It's about 30 to 32 questions for your 2-hour exam. 30 the semester, yeah. So it'll be 30 questions. Back in my day, we had 32. So you're saving about, you have like what, 120 minutes for 30 questions. So you have 4 minutes per question. So it's not, it could be worse. So with that said, right now we're going to look at our operating cash flows. And our operating cash flows are honestly pretty straightforward. Not a lot of heavy lifting there. It's really just understanding what it means. So our operating cash flows are synonymous to the idea of earnings. So what do I mean by synonymous to earnings? So in the question, they may just say, hey, they're making earnings of X per year. So just kind of like put that hand in hand. It's just about the terminology that you want to kind of be ready to deal with. Okay. And then what is the formula here? So the formula for your operating cash flows or just your OCFs is as simple as your sales minus cost times your tax rate. So times TC times your tax rate. Another thing, by the way, is that your operating cash flows could operate as a normal annuity, a growing annuity, a perpetuity. It really does depend from question to question. You just want to be able to apply the cost portion to it in a smart way. Okay, so that's one thing that you want to be able to understand. And then another point, we'll try to go through it fairly quickly. So then we have our net working capital. So our net working capital, what's TR again? By the way, great question. TR is your tax rate. Okay, so TR is your tax rate, no problem. And so net working capital, once again, you don't really need to remember the theory behind it. Yes, it's your working capital, so it's your current assets and your current liabilities. What you want to understand essentially is that we're looking at the change. Whoops, we're looking at the change in net working capital. That's what we're really focused on. So we want to know, how does NWC change every year? That's what we're really, really, really interested on. And an example of how you use that would be as simple as this. So you would do NWC, so net working capital from year 1 minus net working capital of year 0. Do it net working capital of year 2 minus net working capital of year 1, etc. So you'll see what I mean by that when we look at our table. I like to use a table here. It makes it the easiest way to go about it. It's fairly simple and it makes it really, really easy for you. You just need to remember that every single bucket that we're looking at now are crucial, and they may not all be there on your exam, but they're available and it's fair game for them to use it. But you also want to remember that every single bucket that we're going through, so color blue, color red, color green, you always have to discount them to the present value, because that's how we're going to be able to find the present value of our project. Okay, so another step, now it becomes easy. It's kind of just straightforward stuff. Little like quirks that they may add to your exam or to a small question, you never know, is essentially the recapture. So a recapture of net working capital. So the recapture of net working capital, it doesn't always happen, but what you want to know is that this typically occurs at the end of your project. Okay, so this is typical at the end of your timeline for your project. So what does this mean for you? The idea that we're saying that this occurs at the end of your timeline and or your project just means that you need to remember to discount it at the right year. Okay, so remember to discount this at the correct year. So therefore, remember to discount at the correct year. This is like crucial. You'd be surprised how many times this error is done. Okay. Another point that you may see relates to this idea of your salvage value. Okay, so your residual value or your salvage value. Your salvage value, I mean, listen, it's obvious that's going to happen at the end of your project or at the end of your timeline. There's just no other way to go about it. So once again, you need to remember to discount this at the correct year, which is at the end of your project, at the end of our timeline. Okay. Residual value that must be discounted at the end. The end of your project. Okay, and then finally, last but not least, probably the easiest step, honestly, is more so related to this idea of depreciation. And depreciation is typically done in a straight line for the scope of most of your classes actually at JMSB. And we're just going to look at something super quickly. So if you're dealing, this doesn't really always happen to BH, but depreciation, if you do so, must be done in a straight line. So typically done in a straight line. And if you remember Comp 17, this just means that every year, depreciation amount will be the same. Okay, every year, the same. Will be same. Okay. What's cool with the depreciation is that you get to benefit from a tax shield. The depreciation essentially allows, it's a non-cash expense that you're allowed to use for businesses, companies, which gives you a tax shield, which allows you to pay less taxes. Okay, and less taxes is good. Less taxes means more money in your pockets. So we like to look at, sorry about that. We're going to try to look at the depreciation tax shield. Okay. And the formula for the depreciation tax shield is as simple as depreciation expense times 1 minus TR. Okay, actually times TR. Sorry about that. 1 minus TR. So times TR. So now that I'm done doing my classic spiel, we're able to just look at our question and try to identify the different buckets that we need. Okay. This is just something that I think is fairly important. Having these things ready for you for your exam is crucial. It'll make it easier for you. You won't have to remember anything. Okay. So we have this question. What we're going to do now is we're just going to allocate the different segments. So we have Magma Inc., which is considering a new 4-year project. The project will require the purchase of new equipment costing $200,000. So already there, we know that our new equipment will cost us $200,000. So that means that we're making an initial investment towards our equipment of $200,000. So just like that, we know we're dealing with initial investments. So we're going to highlight it in blue. If you remember, what's in blue is what we consider our initial cash flow, i.e. our initial investment. So for that reason, we're going to identify it in blue. But also, really, to be super sharp, if you notice here, we're considering a new 4-year project. This is the timeline of our project. And this may be useful for us when we consider depreciation, because under a straight line depreciation method, we take the value of our equipment minus the salvage value over the number of years. So for that reason, let's highlight this in yellow because this is highly related to depreciation expense and just our straight line method. Now we also know that we could salvage this. Oh my God, I had like a bug there. We could salvage this equipment for $73,828 at the end of our project. Okay, so we also know that Magma paid $2,000 for a search study analyzing the effect on revenue and cost of new projects. Now, what is this for us? Do we consider this as an important cost? Do we consider this as opportunity cost? Do we consider this as sunk costs? What does this mean for us right here? What do y'all think? I talked a lot. Now is the time for y'all to participate. So what does this mean? Is this a sunk cost, opportunity cost, important cost? What is it, Kareem?
I would go between sunk cost and initial investment.
Okay, and we have 2 people, and we have 3. We actually have a lot of people in the chat that said it would be a sunk cost. And the idea why, and you are correct as well, is that this is expenses or expenditures that were already paid out. You know, even if we didn't go through with this project, even if we didn't go through this capital budgeting decision, we would have to pay our $2,000 no matter what. And for that reason, it's already paid. It's already going to happen no matter what. For that reason, this is what we call a sunk cost. Okay. That's what we call a sunk cost. Alrighty. So with that said, now we could discuss the following point, which is this idea of revenue. So revenue is expected to be $100,000 a year in year 1 and will grow at 5% per year. Okay. The expected operating costs are 40% of revenue and net working capital. Okay. So right here, we're talking about revenues. And for that reason, because we're talking about revenues, we're kind of going in the topic of operating cash flows. All right. We're dealing with operating cash flows. And for that reason, we're going to highlight this in red. So revenue is expected to be X amount, which is going to be growing by 5% per year. And the expected operating costs are 40% per year. So these are all things that we're going to need to look at for our operating cash flows. Okay. And just because we want to be quick, we're also discussing our tax rate right here. So let's also highlight that in red because that's going to be super important when we consider all things related to our monies, you know, our cash. And by the way, just really quickly, I made a little like typo here. Right here, we're going to allocate it as being, sorry about that. We're just going to put this as 1 minus tax rate. Sorry about that. So times 1 minus TR. That's something that we need to remember. Okay. So now we have that bucket done. It's pretty clear to us. they're discussing net working capital. Okay, so net working capital, it follows the following trend. It's $6,000, 6,300, 6,615, and then 6,000 for year 1, 2, 3, 4. So this is really important for us because not only do we know what's our net working capital per annum, we'll be also able to figure out what's our change year to year. Okay. Now, what's really cool here as well is that they're telling you that we're going to recapture our net working capital at the end of year 4. So at the end of the project, net working capital will be recovered in its entirety, essentially. Okay, so net working capital. We'll put this in yellow because we're at orange because we're looking at net working capital. All right, so assume net working capital is recovered at the end of the project. Okay, so now we're also going to highlight a few cool other points that are important for us. So we're telling you that Magma has a 10% cost of capital. That's going to allow us to discount. Yeah. So essentially, the revenue will be growing by 5%, not so much our profits. Okay. So we're going to really look at our revenues that are increasing year to year. That's an amazing question, Asho. Yes. So with that said, assume that cash flows occur at the end of the year. And now we're going to tell you, hey, calculate the NPV and decide to reject or accept this project. So now what we're going to do is we're going to allocate every single bullet to the different elements, that we've highlighted in our question. And now it becomes super easy for us. Yeah, we took a lot of time to explain and associate things, but when you become a pro, all you have to do is do the math. So for that, let's just go into it. So what's our initial cash outflow? Can somebody tell me what's our initial cash outflow? What is our initial cash outflow? Is it nice? So yeah, it's minus 200,000. So it's minus 200,000. So CF 0 is equal to 200,000 minus 200,000. Now, obviously, we don't need to discount CF0 because it's happening at year 0. So if we try to discount it, it would literally just be 1 plus 1.10 over the power of 0, which would still give you minus 200,000. Okay. For that reason, CF0 is equal to minus 200,000. Boom, easy like that. We already have our first bucket out the way. Now let's look at our operating cash flows. So this becomes really, really interesting. And we could actually make this easy for us. We don't need to make this super complicated. And I'm going to show you how. Okay. What's interesting with our operating cash flows is that we know our revenues are going to be increasing by 5% every year. Okay, so that makes it a little bit weird for us. Now, some may decide to build a table and just find the revenue figure for every single year and then allocate 40% to that figure. But because we understand our math really well, we could actually follow something easy for us. So let me give you guys an example. We know for sure at year 1, okay? We know for sure that at year 1, we'll be looking at sales minus cost times 1 minus the tax rate. That's fairly obvious for all of us. It makes sense. So what were our sales figure? What were our sales for year 1? If I have to ask you, what were our sales for year 1? What were our sales for year 1? It was given to us in the question. We don't even need to apply any growth rates. Amazing. So Justine says it was $100,000. So our sales for year 1 were $100,000. So we'll have 100,000 minus 40% of our revenue. So what is 40% of our revenue? Somebody other than Justine, what is 40% of our revenue? Because in a question, they tell us 40% of our revenue are allocated to costs. So what is that? 40% of 100,000. 40% de 100 000. 40% of 100,000. 40% of our revenue goes to sales. All right, so Alexander says 40,000, right? Just to make this super clear, such that there's no ambiguity. The expected operating costs are 40% of revenue, right? So costs are 40% of revenue. Revenue for year one is 100 grand. Therefore, for that specific year, cost for year one, it's equal to 40,000. Okay, so 40,000. All right. And then we know that we have 1 minus our tax rate. Our tax rate is 0.30. Now, can somebody tell me what our operating cash flows are for year one? So 100,000 minus 40,000 times 0.7. What is that equal to? What is that equal to? $100,000 minus 40,000 times 1 minus 0.3. Amazing. Amazing. Thank you so much, everybody. Doing great. So we have $42,000. So that's cool. We found our operating cash flows for year one. The thing is, a lot of you, if you didn't do this like already, it's kind of like it's weird. We're like, okay, so do we have to repeat this process every single year? For every single year of our project, and we know this project lasts 4 years? No, you don't actually have to do that. Because we know that our sales will be growing by a consistent figure every year, so by 5%, and because we know our costs are always going to be a function of our sales, all we have to do is actually use 42,000 in our growing annuity formula. Let me say this one more time. Because we know our sales will be growing by a consistent number every year, which is 5%, and because we know our costs are always going to be a factor of our sales, we could actually take our $42,000 right here, we could actually take this value and make it our payment for our growing annuity. So we could plug this in within a growing annuity formula and actually find our value here. So let me show you how we do that. It's literally what we did for midterm one, is what we did with the first chapters of our course, okay? So as you can see, we're gonna use a growing annuity formula. So you could plug in growing annuity formula. To find the present value of our operating cash flows, okay? So before we move on, before we continue with this, does this make sense to everybody? Do we understand that we could find our growing annuity present value like that? Does this make sense to everybody? Am I not losing anyone? We're cool? I'm not getting a yes, I'm not getting a no. I know everybody's tired. I know it's a lot of stuff, but trust me. Perfect. Thank you. Amazing. Cool. So with that said, we could plug this in our growing annuity formula, and we already know what that looks like. So we have the present value of our operating cash flows, which will be equal to 42,000, right? Over K minus G. So that's 10%. 10% minus 5%. We're going to do this times 1. Oh, sorry. We're going to do that. So we're going to do that. We're going to do 1 minus, okay, 1 minus 1 plus G to the power of, I don't know, 1 plus G divided by 1 plus K, power of N. Now we obviously know that G and K are equal to, G is equal to 0.10, so 10%. N is equal to 4. K, no, G is equal to 5%, sorry about that. K, 10%. This is 4. So if I ask you to essentially tell me what this returns, what would our present value of our operating cash flows be equal to? If we use our growing annuity formula. So we have 42,000 divided by 0.05, then we're going to do that times the following. So we'll have, what would be our present value of our operating cash flows? Alexander says 142,626. Is it true? Is it false? I don't know. Who knows? I need one or two other people to tell me, and then maybe it's the right answer. Who knows? Nice, Justine. Okay, one more person, and we'll have our answer here. Okay, what is our answer? Is it 142,626? Is it? One more person, and I'll show you the breakdown. One more person. Nice, perfect. Yes, so that is indeed the answer. So as you can see, it's just 1/5, 1.10, that to the power of 4. And that's going to give us our present value of operating cash flows equal to 142,626.016. So that's our step for operating cash flows. That's all we had to do. Okay, it's literally, it was as simple as that. Now, in this case, we obviously don't need to discount these operating cash flows because we already did them. We already discounted our operating cash flows by using our growing annuity formula. So we're literally done with this step. It's as easy as that. Now we need to move on to our net working capital. And our net working capital isn't so complicated. All we need to use is a table. And we're going to use a table to make this easy for us and to go through the step in a smart way, in an educated way. Let me just change the size. Perfect. So our next step here is simply creating a table for our our change in net working capital. Okay, so we could do it as follows. All right. Have our years, we have So right now, essentially, what I want y'all to do with me is build your table for your change in net working capital. So what we're going to look at is we're going to look at net working capital for every single year, and that was provided in the question. Then we're going to look at the change of net working capital year to year. And from that, once we have that figure, we'll be able to find the present value of the change of net working capital for that specific year. Once we have all those figures, we're going to sum them up together, and that's going to give us our present value of net working capital for this project, okay? Of the change in net working capital for this project. So I definitely suggest that you build something similar. It would be kind of the right way to go about it. And by the way, thank you so much for everybody that's still here. Listen, I know we were going over time, but you're doing great. It's the last question we're going to go through, and then you'll be able to kind of relax and study a little bit more on your own time. So we got this. Okay, so year 1, year 2, year 3, year 4. Okay. Cool, amazing. So now that we have all these different figures, can I ask y'all, what is our net working capital for year 0? According to the question, what is the net working capital for year 0? Is it 6,000, 6,300? Just this, we're gonna look at this first, okay? So right here we have our net working capital. This part right here is simply finding what's written in the text, okay? So in this case, net working capital for year 0 is equal to 0, okay? What about net working capital for year 1? What was written in the text? 6K, amazing. What about year 2? Exactly. Then what about year 3, but somebody other than Alex? Somebody other than Alex. What was our net working capital for year 3? Not the change, just the net working capital in year 3. Thank you so much. Yes. And then somebody other than Justine and Alex, what is the net working capital for year 4? What is the net working capital for year 4? No pun intended. Net working capital for year 4. What is it? 6,000. Thank you, Nolan. Thank you. And Kajal. Thank you so much. Yeah. So we have 6,000. So with that said, now what we want to look at is the change in net working capital. Now, just really quickly, the change of net working capital, what we mean by that, just to be like super duper clear, is we're really looking at the difference. So it's literally year 1 minus year 0, okay? So for year 0, what is our change in net working capital? For year 0, so like the previous year, for this year, like, did we have net working capital before? So you take the previous year, so this would be like -1, -0, but because we don't have any -1, it's just 0 minus 0. So that, for that reason, net working capital, our change in net working capital at year 0, right? Because year 1 didn't happen yet, would be equal to 0. Just to make that like super clear. So we always look at the previous year, right? So for year 1, we're going to look at this year minus the previous year. So we're going to take, and I think this was a little focused. So we're going to take the net working capital we had last year minus the net working capital of this year, and that's going to give us -6,000. So what we do, just to be clear, I'm sorry about that, we take the net working capital of last year minus the net working capital of this year, and that gives us our change in net working capital. Okay, so it's -6K. Now for year 2, what would be our change in net working capital? If we do 6,000 minus 6,300, what would be our change in net working capital? So year 1 minus year 2. Sorry about that. Let's narrowise this. Yes, thank you, Justine. Thank you. Now, what about year 3? Somebody other than Justine, what would be our change in net working capital? Somebody, nice, good stuff. And now year 4, somebody other than Justine, Naomi, Alexander, my guy, yes. Perfect. So now what we need to do is we need to discount our change in net working capital with our cost of capital. Now our cost of capital, by the way, is equal to 10%, as said in the question. So 0 discounted by 10% will give us 0.100, like that's guaranteed. What about year 1? What is our present value at year 1? So 6,000, minus 6,000 divided by 1.1 to the power of 1. Nice, perfect. So minus. Okay, what about at year 2? What is the present value of that year? What is the present value of that year? So obviously we're discounting at 2 years, so we're taking minus 300. Nice. Yeah, Kareem, what's up?
Just wanted to make sure, why is it negative? Is it because we're paying it out of our pocket, so it's negative?
That's one way to look at it. The easiest way to go about it is literally just a change formula. So we take the first year, so like the past year minus this year, and we're seeing that the change is obviously non-existent. So for that case, we're going to put it as minus 6,000. It's really as simple as that. But the way you looked at it as well makes sense because we added money to our net working capital. We added value there. So we paid $6,000 out of our pocket. That's one way to look at it too. It's pretty clear. So for year 3, minus 315. Thank you so much. And then finally, for year 4, 615 over 1.1 to the power of 4. What would that be equal to? $420.05. Amazing. So if we add all of them up, what will be the present value of our change in net working capital? Exactly. Thank you, Alexander. So yeah, that would be the value of our change in net working capital. Perfect. So with that, we now have our answer for our change in net working capital. Now what we want to look at is we want to get a better sense of what happens in the case that, let me just check something out. Cool. Now that we have that, we're able to move on to the next step, which is the recapture of net working capital. Now for the recapture of net working capital, this is just a small nuance that I want you to understand, is that in the question, they make it a little bit vague. So they say that assume net working capital is recovered at the end of the project. In this case, what we mean is that we're recapturing the net working capital at the end of year 4. So we're essentially recapturing $6,000, okay? That's what we're getting back. We're not getting back all of the net working capital put in. We're just getting back this, okay? So that's just something to consider. So what this means for us is that we could literally compute the present value of the recapture of net working capital as follows, okay? So this literally just means that you're going to recapture $6,000 at year 4, okay? So that means that you're going to recapture $6,000 at year 4. Therefore, no pun intended, you need to just discount this value at T4. So essentially, this is literally it's going to be as simple as this. 6,000 over 1.10. Now, what is this equal to? If I need to ask somebody other than Justine and Alexander, so you guys are killing it. What is 6,000 divided by 1.1 to the power of 4, which will be the recapture, the present value of our recapture. Thank you so much. Yes, that is the answer for us. Thank you. So yeah, this is the value of our recapture. Nice. So that's the present value of our recapture. We could say present value of NWC recapture. Cool. So now we have that. And last but not least, okay, actually not even last but not least, I believe we have one last step to go about. Sorry about that. But this step is really straightforward. The last few elements are kind of like, you know, straight shooting. It's not very difficult. All that you have to do is do the following. So we're looking at our residual value. Now, can somebody recall what's our residual value? What is our residual value at the end of year 4? Exactly. Amazing. So it's equal to this much. So now that we understand that, and we understand that we're going to be getting that money in, right? It's like if you sold a car 5 years from now, the money's going to go to your pockets, nobody else. So we're applying the same idea here. What we're going to be selling in terms of equipment at year 4 is what's going to come back into our pockets. So what we need to do is the same thing. We need to search for the present value of that residual value that will be earned upon the exit or upon year 4. So in order to do so, what you have to do is literally discount that amount by our cost of capital. And that's going to give us a specific dollar figure. And that dollar figure is exactly what we're going to essentially call our present value of our residual value. So what is that equal to? What is this equal to? Yes, you are correct. Exactly. So that's what we call our present value, our residual value. So that is the present value of our residual value. Now, last but not least, we just need to look at our tax shield. Our tax shield could be done fairly easily. So the first thing that we need to find, though, is our depreciation expense. And we know that we're using our straight line method. So because we know we're using our straight line method, how do we find our depreciation expense? What we're going to do is essentially take our face value minus our residual value over the time horizon. Now, can somebody tell me what this would be equal to? I'm gonna cheat a little bit and not tell you the value. So what would be our face value minus our residual value over our time horizon? That's gonna give us our depreciation expense. But what is that dollar figure? What is that equal to? What is that equal to? Okay, maybe you're right. I don't know, Alexander. Maybe. Yeah. Well, this is our depreciation expense. Just to be super clear, this is our depreciation expense per year per annum. Okay, so that's our depreciation expense per year. For us, you are correct. So that is our value. That is our depreciation expense every single year. Okay. So we have 31,544. Okay. But that's not the end of it. We now need to look at our tax shield. We want to seek what's the depreciation tax shield for us. Okay. So in order to find that, what we need to do is pretty straightforward. We need to take this and times it by our tax rate, which is 0.3. So what is 31,000? How do we get 31,544? So how you get it essentially is pretty straightforward. What you're going to do is you take your face value, okay, Justine, which is, if I'm not mistaken, $200,000. So you're going to have $200,000 right here, minus 73,828, and you're gonna divide that by 4. And if you do that, you're gonna get something along the lines of 125,000 divided by 4, so about like somewhere around 31,000. Yeah. So Justine, does that make sense? Like I just did some quick math to like show you like the logic there, but yeah, so that's how you get it. Amazing. So and then Kareem, you're totally correct. So 30% times 31,544.25 gives us 9,463.275. So yes. Perfect. So what I need y'all to understand now is that this value that we just uncovered, 9,463, 0.28 is essentially our tax shield every single year, okay? That's our tax shield every single year. Therefore, we need to be able to look at this, essentially the present value, or the sum of the present values for every single year. So you need to apply the tax shield for year 1, year 2, year 3, and year 4. In other words, you need to discount 9,463.28 for every single year, okay? So I think the most logical way to go about it is by plugging this in within your CF formula on your computer. Wow, I sound like a dinosaur. On your calculator. So you could put CF0 as literally equals 0, but then you could put CO1 as equal to 9,463.28, like that. And then you could put a frequency of 4. So you'd have frequency equal 4. Then you press enter, and then all your other cash flows are equal to 0. Then you could go into NPV, set your present value to 10, your interest rate to 10. Then you press enter. Then you could go compute. It should give you the value that is this. So 29,995 or 200 or 29,996, something along those lines. So that's a fair play amount. Or you could do it just every single year. You could try to discount it every single year, and that works as well. Okay. Let me just, yeah. So that's how you'd go about it. And for that reason, you could find the present value of depreciation tax shield is equal to 1,997. 32. Okay. So does this make sense before we move on to the last part, the most beautiful part? You got another value. What did you get? What did you get? Did you set your CF? So let me just show you, by the way. So CF0, I could write it. Essentially, Justine, what we did is that you went into your CF part right here, and you have this on recording too, by the way. So you went into CF, right? Then you look at CF0, you place it at 0. Then you go down, or I'm sorry, you go down. Then for CO1, right? So cash flow for year 1, you could literally just plug in 9,463.275. You're going to press enter, right? Once that's done, you're going to go. Yeah, you could do that too, man. 100%. Yeah, 100%. If you want to use the formula, you could definitely use the formula and just treat it as annuity with payment and then allocate your 10% as your K. 100% you could do that. Those two ways. What value did you get? You got 43,000. You'd have to send me a picture. Send it to me on Messenger. I'll check it out.
Yeah.
So
it's because like I did the 9.9463 point. I got a different payment. I got 9,463.9, and then after 4 years, 4N 10 IY 0 0 PV, and then after I calculated for future value, and I keep on getting 43,000. Wait, what?
Calculating for present value, right? Because we're discounting every single tax shield.
Oh,
zero. Yeah. By the way, that's a really good point. So everybody, what we're doing here, like at the end of it all, we're just looking for the present value. That's what we're seeking, right? We want to know if the present value of all these different buckets is bigger than our initial investment. And that's going to tell us if we accept and or reject this project. So that's a nuance there. Always seeking for PV. So Faraz, how did you get the present value of depreciation tax shield? So how did I get this? Essentially, this is my depreciation expense, right? But we're going to allocate our taxes to it to find our tax shield, which is 9,463.28. Then you need to discount this value for every year. So just to make it super clear, I'll add a little element here. So what this means essentially is that what you'll do is you take this value, and you're discounting it for every single year. That's essentially what we're doing here. And that's what we did through our calculator. Our calculator allowed us through the CF function to do it in 1 second. But you could also go about it like this. It's really up to you. Yeah, Kareem, what's up?
I just want to make sure, why do we need to find the present value of like every, calculation that we do? That's the only thing that I don't really understand.
Yeah, so essentially, it's a really good question. So what we're trying to see here is that we're trying to see if the present value of all these different buckets offset our initial investment of $200,000. Because if it does, it means that our NPV is greater than 0. And we remember from chapter 13 that if NPV is bigger than 0, that means that we must accept the project, right? We're trying to just allocate the present value of all these different buckets to see if they once again offset our initial investment. And that would mean that this is a good project for us, because even the money that we would get today is greater than what we invest today. It means that this is a really sound investment, right? Because there's no opportunity cost like for us, right? So that's why. And then Faraz, so how you would calculate it with your calculator, once again, is by using the CF function, right? CF, you go CF0 equal to 0. You gotcha, exactly. That's how you'd go about it. Then you compute for NPV. So now, all that is left to do for us is simple, right? It's the last step, is literally adding all these values together, okay? So let's do it together, minus 200,000 plus 142,626 and 16 cents plus minus 5,519.09 plus 4,098.08 plus 50,425.52 plus 29,997.32. And that's going to give us the present value, the net present value of our project. And can somebody tell me what that gives us? What is the net present value of our project? What is the NPV? Yeah, no, all of y'all are going to have access to this about maybe an hour after the thing is going to be posted on a member area. So what is the sum of everything that was highlighted in purple? What is the sum of everything that we just discussed? All of our present values, if we add them up together, including our initial investment, what will that give us? So minus 200,000 plus 142,626 plus minus 519.09 plus 4,098 plus 50,425 plus 29,996. What would that give us? Not quite. It's close though, a little bit. So just to make it clear, it's probably just a small miscalculation. So minus 200,000. Not quite. So what we're doing, and we can do it together. Yeah, exactly. So minus 200,000 plus 142,626.016 plus minus 519.09 plus 4,098.08 plus 50,425.51 plus 29,000 997.32. And that gives us a different amount. If you add all of them up together, that gives us a different amount. It's not 74,000. It's not minus 28,000. You just need to add this up with this, with this, with this, with this, with this. Minus, this is a minus 200,000. There's only two minuses, this and this. The rest is all added. What is the value? What is our NPV? Maybe Perez is right. Maybe he's wrong. Maybe he's right. Who knows? I need two more people to tell me if y'all got the same value. Maybe Perez is right. I don't know. Not sure yet. What did y'all get for the NPV? So we add this, we add this, we add this. I mean, I have it on my calculator, guys. It's right here. There's just no other way to go about it. Exactly. That is the value. 21,627.83 or 0.84, 0.85. I think really the best step to go about it is probably just check mark them every single time, and then kind of just look at it at the same time. But I get it. It is 9:30. I understand, and thank you everybody for like staying up until now. I really do appreciate it. But that is a correct answer. So my 21,627.84, 85. It's all the same thing. So yeah, that is the big budgeting question. But by going about it in this fashion, you really cannot make mistakes. Really, it's annoying. You know, there's no other way to go about it. It's annoying, but this kind of removes some of the ambiguity, and that makes it slightly easier for you. So with that said, that's what we have for today. What I'm going to add in our member area is the solutions to everything that's in this workbook, as well as the recording for tonight and the recording from exam 1 and exam 2. So you'll be able to really look at every single element that you need to really focus in on and master for Saturday or Friday, I believe. And you're going to be doing amazing. This is literally the worst of it. And trust me, it's going to go fine. So thank you, everybody. Unless you have questions for this question really quickly, but other than that, thank you so much for taking the time. Thank you for staying that extra 30 minutes. I appreciate it. And I know y'all are going to do amazing on the exam. Totes amazing. My pleasure, my pleasure, my pleasure.
Thank you.
My guy, I got you.
And we'll stay in touch for after the final. Maybe we'll go out for a drink.
Oh, you already know
if we have time. Yeah, I know you're done. It's just a matter of time. Fuck. It's no time.
So,
yeah, exactly. Have a good night, bro.
You too. Thank you. Have a great evening, everybody. Thanks for taking the time. I appreciate it.